Okay, let's see if it's all working. Looks good. All right, excellent. Well, alerts are still only going to play for Twitch for some reason. I just can't get them to work for YouTube. But I can see on the activity feed when I look at it. Anyway, today we're going to look at implementing diffuse lighting. So, in between yesterday's stream and now, I added a model extractor to render GLTF models. So we've got the famous Sporza here, which I'm sure you guys are familiar with if you've seen any rendering tech demos or anything. So nothing crazy, just rendering the normals as colors, scaled to a value between 0 and 1. So yeah. Let's have a look. Okay, I'm going to remove some random print stuff that I had in here when I was getting this working. I'm going to extract this. Actually, I'm not going to extract this yet. Let's look at the lighting first. Okay, so ambient lighting by itself, which is this up here, doesn't produce the most interesting results. That's correct. So if I take the ambient lighting from here, if we add that to our shader, let's have a look at the shader, simple 3D fragment shader. So we'll try out this float ambient strength with an R is 0.1. And so we're going to multiply that by the light color, which we don't have because in this example they set up a different, I think a uniform buffer perhaps, but I'm just going to say the light color is going to be white. So we're going to multiply ambient strength by light color. And we'll make this variable, this is going to be a vec3, light color is equal to 111. And we want to multiply the ambient by the object color, which we don't have, but we do have a fragment color. I wonder if that's going to be a problem. We might actually need object color, because fragment color is not, I guess that is the color of the object. That should be fine. Oops. So object color is not object color. I'm going to call it frag color, and then this is going to be result. Okay, and that's probably just going to make everything look really dark. So I need to actually compile this shader. Okay. Okay, that did not do anything apparently. Interesting. I would have thought multiplying it by 0.1 and then multiplying the colors would have done something. Did that actually compile? There's too many things in here. Simple 3D did successfully compile. Okay. Oh, I think I also have to compile the program because I used load, which compiles the source code into the program. Well, it doesn't compile the source code, it compiles the SPV. Yeah, there we go. So we got a really dim scene now. What I was expecting. So basically, I guess I didn't really go over why we're doing this, but I want to implement this thing called Radiance Cascades, which looks really cool. However, I started looking into it, and the implementation is a kind of crazy. So it's a new lighting model. I think it was made by the PoE2, Path of Exile 2 developers. And it looks really nice. I'm not going to explain how it works, but the 2D version seemed simple, and so I was like, okay, I'll look at trying to implement that. And then I was looking at people doing it, and it was just kind of crazy. So I thought, okay, I'm not that experienced with 3D graphics yet, so let's work our way up from really simple lighting to really complicated lighting. So we're going to do that. So don't worry about this. Go back to our Learn OpenGL, great website. We are of course not using OpenGL, but it doesn't really matter because we're using the GL shading language, so it should be the same. So we've got the ambient lighting, and as they say, it doesn't produce the most interesting results. Correct. Diffuse lighting is sort of like the sunlight. At least that's how I think of it. Oh no, that's directional light. So this is going to be... Okay, interesting. So they actually have a light source pointing down at this thing. This might be a problem. Is there something in here? Like... I just want a sort of simple directional light that comes from the sky. Well, maybe we can just figure it out by doing this diffuse lighting. So, to the left. What do you mean to the left? You mean on this side? We find a light source with a light ray targeted at a single fragment of our object. Okay, this is a fragment, I guess. We need to measure at what angle the light ray touches the fragment. Okay, that's fine. If the light ray is perpendicular to the object's surface, the light has the greatest impact. That makes sense. So if it's straight down, it's going to reflect the most light. To measure the angle between the light ray and the fragment, we use something called a normal vector. Yep, so we need to get the normal, which is what actually we already have. So the color of all of these is the normal of the surface. So we've already got access to that data, which is good. The angle between the two vectors can then be easily calculated with the dot product. Yep, that makes sense. So this, and then a dot product, and then if it's a line, the dot product will be 1 or -1. I guess if it was behind it, it would be -1. Is it 0? Does dot product go closer to 0 or further from 0? I need to... Well, I'm sure we'll find out shortly. The angle between the two vectors can then be easily calculated. Yeah. The lower angle between the two unit vectors, the more the dot product is inclined towards phi of 1. The lower the angle. Yeah. So when the angle between both vectors is 90 degrees, the dot product becomes 0. Yeah, so it's 1, 0, and then -1 behind it. Okay. Note that to get only the cosine of the angle between both vectors, we will work with unit vectors with vector length of 1. So we need to make sure all vectors are normalized. Otherwise the dot product returns more than just the cosine. Okay. I'm pretty sure the data is normalized. Let's have a look. So we'll just have a look here in the pipeline, actually just have a look here. Drawing indexed vertices. View the contents as spec3s. Oh, those are not normalized. Interesting. Maybe I should normalize them because I'm doing it on the CPU here. Where is it? Yeah, so I'm just change the range to between 0 and 1, and then I'll use this. What's that going to look like? Okay, it still looks similar, although I know it's not the same. And if we have a look at the data again, where are we going? Here, view it as a vec3. Yeah, that looks not normalized either. Wait. Yeah, that could be. I'm pretty sure it must be. They should add up to 1. No, they should have a length of 1. So if I get this vector here, 0.37, where's somewhere I can put this? Zero 0.373, 0.8144, 0.44454. Okay. Okay, I want to get the length of this. Okay, here we are. The length is 0.99996. Yeah, okay, so they are normalized correctly. That's good. I wonder if they already were. That's fine, I'll just leave it for now. Okay, so that's good. Where were we? Yeah, the resulting dot product returns a scalar that we can use to calculate the light's impact. Yes. So what do we need to calculate the diffuse lighting? We need a normal vector, we've got that. We need the directed ray, which is a direction vector that is the difference between the light's position and the fragment's position. So to calculate this, we need the light's position and the fragment's position. Okay, that's fine. Okay, this is going to tell us about the normals. That's all good. Okay, they're going to set a light position, which we don't currently have. And a frag position. Okay, so we need to pass this into the fragment shader, I guess. Model times. Right. Okay. That is the vector. Alright, so we need an out variable here. Very good. Oh, interesting. They're passing the normal. We're passing the normal as a color, aren't we? Yeah, which is fine. We can just use that. That's okay. So they're normalizing the normal again. We don't need to do that. Although maybe it would be more efficient to do it on the GPU instead of on the CPU. I mean, it definitely would be. All right. So we want to go to the fragment shader. This might be confusing because our frag color is actually our normal value, but that's okay. So light direction is going to be light position minus frag position. Okay. That makes sense. Okay, we don't actually have a light position, so I'm going to just set one here. We'll set it to 0, 40, 0. Let's see what that does. All right. We only care about the direction. That's cool. So we're going to get the calculate the diffuse impact of the light on the current fragment by taking the dot product between norm and the light direction vectors. The resulting value is then multiplied with the light's color to get the diffuse component, resulting in a darker diffuse component the greater the angle between both vectors. Yep. Okay, so oops, float diff is equal to dot product of, why do we use max here? Because it can't be less than 0. That makes sense. Otherwise we'd have weird stuff happening. Yeah, okay. I gotta remember to put semicolons. I'm so used to not using them. The angle is, yep, he just answered that question right there. Let's stay away from lighting for negative colors because it's not defined. Kind of interested to know what that would look like. Maybe we'll experiment with that shortly. Okay, if we have both ambient and diffuse, we need to add them to each other and multiply that by the object color. Okay. So it would be ambient plus diffuse, which I haven't made yet, because I need to multiply it by the light color. Okay, that's the ambient light color. So, okay, that's fine, we can change those. Let's see what happens if we compile this. Oh no, I have to compile the shaders first. I'm gonna have to change how this works. Okay, we got an error, that's good. Cannot convert from a vector to a float. Line 13. Oh yeah, of course. Can I convert from a vector to a float on line 17? Right. Yeah. Good, and compile the program and run. Okay, we got what looks sort of like directional light straight down. So I think I should probably not use straight down. I should use some kind of angle. Let's go on the x-axis, maybe 10 units. I need to compile this again. Okay, this is getting annoying already. I'm gonna have to change this. Okay. Well, that looks the same. I think maybe because I'm using the normals as the color, I should probably not do that. So where is the color? Frag color. So we're gonna still bring these in. I'll bring them in as the normal. I don't need to normalize. Oh, I already did. That's fine. Okay. And with the frag color, I'm just going to set to something like some kind of mid gray with a tint of red, perhaps. I haven't got texture loading yet. Alright, there we go. That's a little bit better, I think. I guess. I can't really see. Maybe because the light's so high up. If I put it a bit lower. And actually, I'll just put this on a 45-degree angle and we'll see what that looks like. I need to do this first. Okay. Ah, I think that might be the x coordinate on this side. So the light is sort of up there somewhere. Actually, why don't I draw something up there? Can I do that easily? I do need to add functionality to do that easily. Well, I'm actually just going to change the side here for the z-axis. What does that give me? Yeah, I can kind of see, I think. Definitely some darker sides. Well, anyway, it looks kind of interesting. Guess we'll just move on. Starts to look like an actual cube, that's correct. So apparently, because we took a bit of a shortcut here, we need to do some more work to get the correct normals. Interesting. I don't know if that applies to us because we're doing a different thing. But I have a suspicion that what we should do... Well, we actually just pass in the normal here. We don't multiply it by the model like they said to. World position is just in position. This is the wrong shader. Okay, I'm just going to delete these other shaders. I'm not using them anyway. And they're in my Git history. Okay, now we only have the two shaders that we're actually using. Vertex, no, that's the wrong thing. I should delete that too. Okay, but there we go. Fragment, okay, vertex shader, fragment shader, great. So we are doing this frag position equals model times blah blah blah. But the model is just an identity matrix because we didn't move it. So I think this is doing nothing right now. Also, I want to see what happens if I don't normalize the normal in here. It looks pretty much the same because my build step. I'm going to change this right now. I think that will work. Build shaders. Actually, I can just call this maybe. Cool. That's annoying. Press any key to continue. I'm going to get rid of that. Where is it? Pause. Yeah, get rid of that. Okay, let's just make sure this is working. In the fragment shader, I will change the color to a more vibrant red. That did not change anything. So it tells me this is not working. I think I have to call exec after all, perhaps. Exec is not recognized. Is it not exec? CMD/K maybe? Or is it /C? Okay. That did everything. Built the shaders, built the code. There we go. Cool. Excelente. That side is definitely darker than that side. That looks good. Cool. So was that a result of this? No, it's still darker. But it looks weird. Maybe it's just me. Alright, cool. Well, time to move on for now. That's okay, I think. We're just gonna... Okay, let me just skim through this real quick. The calculations of the fragment shader are done in world space. So basically, we need to do something to the normals. They're only directions, and they don't represent a specific position. That's correct, yes. I was wondering about that, actually. So that means, regardless of anything occluding them, then they would have the same light applied to them, just based on the direction, which I guess is another whole thing. So there's a different model matrix specifically tailored for normal vectors. It's called the normal matrix, and it uses a few linear algebraic operations to remove the effect of wrongly scaling the normal vectors. There's an article on it here, if it still exists. Oh, it does. The GL normal matrix is present in many vertex shaders. Mathematics for 3D Game Programming Computer Graphics by Eric Lengill. So... Okay, this is the problem that he just outlined. Okay. Right. The normal matrix is defined as the transpose of the inverse of the upper left 3x3 part of the model matrix. Okay. Transpose and inverted. Yeah, okay, gotcha. We haven't discussed inverse and transpose. The vertex shader can generate the normal matrix by using the inverse and transpose functions in the vertex shader. Huh. So we could actually do that at runtime. Is that what I'm getting? They're costly for shaders. Okay, so we don't want to do that. That's weird. Why would it be costly for shaders? Is there a lot of... Which one? Inverse. What is an inverse matrix operation function? I'm going to write programming so we get an actual results that I can read. Okay. I messed up. So the inverse of a matrix plays the same role in matrix algebra as the reciprocal of a number in division does in ordinary arithmetic. I see. Okay, can you show me actual implementation? This is not implementation. Why am I looking at this? I can just look at the linear algebra library here. General probably. Inverse. Matrix 4x4 inverse. Right, so is it expensive because it's got a divide here? That's the only thing I can think of. Or what is cofactor? Cofactor loops through all the elements and does a matrix minor. That doesn't seem too expensive. Determinant. Neither does that. But that also does a cofactor. Wait. Isn't that a loop? Odd. Okay, let's have a look. All right. Let's stop going down that rabbit hole right now. If you're not exhausted already, we can start finishing the Phong lighting model by adding specular highlights. Specular lighting is based on light's direction vector and then object's normal vectors, but this time it's also based on the view direction. Okay, that's cool. Let's have a look at that. Okay. If we think of the object's surface as a mirror, specular lighting is the strongest wherever we would see light reflected on the surface. You can see this effect in the following image. Gotcha. So this is a reflection vector. I see. But wouldn't the light be reflecting in all kinds of angles? I guess this is just a really... This is the strongest angle because it's 90 degrees. But the strongest angle would really be... Yeah, that would be the strongest angle, right? Yeah. Because the reflected vector. Okay, gotcha. Okay, we calculate the reflection vector by reflecting the light direction around the normal vector. Okay, got it. Then we calculate the angular distance between this reflection vector and the view direction. So we want to calculate theta here. The closer the angle between them, the greater the impact of the specular light, which means we see highlight when we're looking at the light's direction reflected via the surface. Gotcha. The view vector is the one extra variable we need for specular lighting. We can calculate using the viewer's world space position and the fragment's position. Then we calculate the specular's intensity. Multiply this with the light color and add this to the ambient and diffuse components. We chose to do lighting in world space. Most people tend to do it in view space. In view space, the viewer's position is always 0, 0, 0. However, calculating the lighting in world space is more intuitive for learning. You still want to calculate lighting in view space if you want to transform all relevant vectors with the view matrix as well. Right. It's okay. We can use world space. That's fine. So we're going to need to add a uniform variable here to our fragment shader. Yeah. So that's okay, we can do that. So I need something like this for the fragment shader. The binding, I think we can use the same binding because it's a different shader. So we're going to just set a vec3, which is going to be player position. Hey Alex, how you doing? HLSL doesn't provide inverse, unlike GLSL. Really? I wonder why. Is it because it's too expensive, or they think it's too expensive? So if we have a look at our uniform push, it's pretty simple. I think we can just make another one here called fragment uniform push. And it's got exactly the same parameters. In fact, it's going to be exactly the same, except this word is fragment instead of vertex. And I'm just going to push the player position, which I'll make in a second. It's going to be size of vec3. I can leave everything else. Actually, I don't need to do player position. I can do camera position. Okay, I think that will work. That's cool. Now we need a strength for the reflections. Okay. Specular strength. Alright, let's do this. Hey Alex, you've implemented a bunch of lighting in your engine, right? I saw you had reflections and everything. Shadows. I'm pretty sure I saw shadows. Why am I using vec3? I need a float. Okay, so the view direction is view position minus fragment position. Okay. Reflect negative light direction by norm. Okay. Okay. Now we've got the fragment towards the light source. I just went AFK for a second. Light direction vector is currently pointing the other way around from the fragment towards the light source. To make sure we get the correct reflect vector, we reverse its direction by negating the light direction. Okay. What's left to do is actually calculate the specular component, which is going to be this. Specular component is maximum of the dot product of the view direction and the reflect direction, and can't go below 0 and to the power of 32. Okay. So power max dot view direction. Was it reflect direction? And 0. I never know. Do I have to put 0.0 in GLSL? It doesn't seem like it. A lot of people do it though. specular strength times spec times light color. Oh, this is not a float. Yeah. Okay. So this power value is going to be the shininess. Okay. Interesting. Right. I see. So we add it to the ambient diffuse, and that's it. Okay, so they're all equally equally affecting the final light, which I guess makes sense. And then if you want to scale one up, you would scale it up in its own calculation somewhere. Well, what does that look like? Don't know. Where's the light? The light must be that way. Oh yeah, that looks kind of shiny, I think. It's probably going to be shiny inside too, because there's no concept of inside or outside. I don't know. I'm going to bump this up. Yeah, it was successful. Okay. It would be helpful if I knew where the light was. Maybe I should do that. But it's got to be that way. Somewhere. It looks like that looks shiny, right? Still pretty subtle, I would say. That looks less. No, because it's this way. Okay, I think that's working. It's just hard to see. So I'm gonna do something about that. What shall I do? Well, instead of having the same color as the light color, I'm just gonna multiply it by nothing, and then that will be white, right? Wait, the light color is white. The frag color is this color. Okay. Let's bring this closer. Actually, if I put it directly above, we might get an interesting result. Oh, that's not above. So the light's somewhere here. Cool. Interesting. Okay. It doesn't seem to care at all about obstructions, which makes sense. There's no code to do that. Still, this is quite a nice look for something really simple. I mean, yeah, I like that. I'm going to change this color to have a bit more blue in it. We might get something. No, not. That's green. Bit more blue. Oh, that's too much. I need it to be less saturated. That's way too much. Whoa. Oh god. Right. Yeah, I was thinking something a bit more like this, but maybe slightly brighter. I don't want it to be straight magenta, but that's what we got right now. Okay, I don't know why I'm messing with the colors so much. It doesn't matter right now. Anyway, that's all good. We'll actually just make it red. And what do we got next? So we've got a Phong lighting model. That's cool. When the Phong lighting model is implemented in the vertex shader, it is called the Gurand shading. I actually like that kind of more. It looks cool, a little bit lo-fi, which is sort of what I want. So maybe I'll try that out. But in the meantime, I want to try, what was the negative light values, right? So what happens if we do that? We just get rid of this. Well, I guess it's just black, which is fine, I suppose. But yeah, it would be black anyway. I thought maybe something weird would happen. Right now the light source is a boring static light that doesn't move. Try to move the light source around a scene over time. Yeah, that's a good idea. Let's try that. Okay, so I need time, I guess. I think I can pass time in from the outside. Or I could just pass in the light position. And make a little struct here called something fragment shader uniform. I don't think we can just make an anonymous struct, right? Yeah, it's not gonna. Default parameters only allowed for procedures. Yeah, I'm pretty sure you can't do this in Odin. You can do it on a type. You can make an anonymous struct on a type, but not just randomly, I'm pretty sure. Doesn't matter. I just want to make two vec2s. And we're just not vec2s, vec3s. And the first one is going to be player position, which doesn't need a name. Camera position, and then we're going to put the light position. So light position, which we need to change over time. Light position equals, I guess we'll do, I'll declare it up here. So it's just going to be 0, 0, 0. Maybe I'll actually put it as 0, 10, 0, and then we'll rotate it around a y-axis using, actually no, we'll rotate it around the z-axis. How do I do that? Is that arc sign? I also need to get the time from somewhere. Maybe SDL has something for that. Get time. No. Let's see. I've got it here. Time. There's a lot of time stuff in here. Get current time in ticks. Oh, what am I doing? Odin has this. Time.now. Oh, I guess I want a delta time actually. Is there a delta time? No. Just when you're moving the mouse you can get the delta. Okay. Although if I multiply this by time dot is it seconds? Duration seconds? Yeah. This is not a duration. What am I trying to do here? Start time. Time.now. Time.now. Time.diff. The start time is start time. End time is end time. Now we've got a duration. Now we can do time dot seconds. Duration seconds. There we go. Okay, now we have a floating point 64 number, which we're going to cast to a floating point 32 number, and then we're going to use, I guess we'll just use sign on it, and we will say, not camera, light dot position dot z equals this. So light position. Multiplied by, let's say 10. So that should get us going like this, I think, going back and forward, right? No, I didn't actually use that, did I? Light position. Oh. Uh-oh. I think my shader's messed up. Yeah, did I do something weird? Let's see. Uniform buffer object, use descriptor set 1, binding 0. If a resource variable is declared in a shader, a descriptor slot in layout must match the shader stage. Oh, right. I think when I make the pipeline, I didn't set that we have a fragment shader buffer. Here we go. Okay, that's still a problem though. BK shader stage vertex bit. Oh. Yeah. I think I messed up that function that I made earlier. No, that looks... Okay. Do we have to make the uniform buffer? Yeah, I didn't think so. I think SDL makes it. So the problem is... Ah, yes, this is wrong. I need to push in our fragment shader uniform And size of, well, vec3 times 2. That'll do. Okay, well that was one thing that was wrong. There's more that's wrong. Let's have a look at this again. Okay, the VK descriptor set layout binding stage flags was VK shader stage vertex bit. The Vulkan spec states if a resource variable is declared in a shader, a descriptor slot must match the layout's shader stage. I think I need to look at the SDL.h file again and look at slot. There we go. There are 4 available uniform slots per shader stage. You could write your vertex shaders to read the counter matrix. Okay. Yeah, but where are the stage numbers? I saw them in here yesterday. Specifies the pixel format. No. I wish I could just remember one of the keywords that I needed to search. It's like slot, but slot apparently is not a slot is a thing. Okay, slot 0. That's the thing I was just looking at. Let's go down. Let's go down. There was a list of the slot numbers. They're predefined. Okay, we're back at the top again. Bit of a problem. Okay, nope. Okay, need to make sure my eyes don't glaze. Otherwise I won't catch it if I scroll too fast. When you call bind vertex properties, you specify the binding slots. Okay, I feel like we're close. Was it even in here? I think it was. Alright. Nope. No, yes. Yeah. Here it is. Okay. It's in the pipeline section. Okay. Alright, so we've got... Okay, read-write storage buffers followed by read-write storage buffers. So, following resource sets. Set 1, read-write storage buffer. Followed by read-write storage buffers. Not read-write storage textures followed by buffers. Okay. 2 is uniform buffers. Hang on, I'm using set 1. And that was working fine. That's weird. Right? Because we're getting the model view and projection. And if I set this to 2, like what's going to happen now? We're going to crash. Okay, I'm confused now. I guess it's... Yeah, I'm not sure. Well, that's what I thought the problem might be. But it's not. So, let's compile this. Is it because... No, it's a different shader, so the binding should be 0, right? Sets 1. This doesn't matter, right? Uniform buffer object. Is this... Why do we have to name these? I don't actually understand. Why do we name uniform buffer object in... To clearly identify the data it contains and its intended use within the shader. Yeah, great, but it's more like these variables become globals to the shader. So what's the point of naming them? I guess it's for a grouping. I guess you could group it. Like this uniform is for this one's for this. Okay, so yeah, I'm confused because I'm using a different set than it says here and it's working, but if I change it, it crashes. A bit confusing. Like if I change this to set 2. I'm pretty sure I didn't set the set anywhere in here. Uniform push. Oh, there is a slot index actually. But that's for the binding, right? I think that's for the binding. Okay, let's read the message again. Yes, thank you. Okay, so we got a VK object type shader module. So I'm making a shader. I think it's when we make our pipeline, right? Got the pipeline layout here. So we're calling create graphics pipelines. Okay. It's in the stages 1, which is a fragment. It uses a descriptor, set1, binding 0, variable uniform buffer object. Okay. But the VK descriptor set layout binding stage flags was vertex bit. I don't know, is this just complaining because the name is the same? I hope not. No. So let's look at the pipeline again. Pipeline. All right. Okay, we've got a fragment shader. Entry points main. Stage is fragment. Number of uniform buffers is 1. Correct. Maybe there's something else I missed here. Vertex buffer descriptions. 6 times. Oh. Wait a second. Yeah, I didn't add it to the... Wait. Oh, no, that's the pitch. This is the vertex buffer, not the uniform buffer. So there's these vertex attributes, this vertex buffer, there's 1. Down here, vertex input states. Okay, no multi-sample, we don't need that. I'm at a bit of a loss here. I don't see what that error could be referring to. What does this page say? If my computer doesn't crash when I click the link, which can happen. the Vulkan website is very heavy. Oh, great, thank you. Okay, here we go. Loading. Please wait. Still loading. Man, this website is great. I have gigabit internet, by the way. Okay. If a resource variable is declared in a shader, a descriptor slot in layout must match the shader stage. Okay, so we're looking for something in layout. Of course, we're not using Vulkan directly, so it might be a bit different. So interesting. Why is there a vertex input state? I guess the fragment shader is past the vertices from the vertex shader, so we don't need an input state. I'm at a loss. Okay, it's not the depth texture. Oh god. So here's the layout. See, I thought we were already passing in player position, which is why I'm confused now. Oh. Is it STD140 strikes again? What is the layout rule for STD140 again? Yeah, I think it's vec4s, is that right? Blah, blah, blah. Okay, here it is. A 3-component vector are 4 times the size. Wait, what? Yeah. Damn it. Is that what's happening? STD140 strikes again. How many times am I going to have this problem? Alright, so we've got to make this... Where is it? This is going to be vec4s. And it's going to be... I guess, can we do this? X, Y, Z. 1. Expect 4 values, got 2. Isn't it swizzling? I know there's swizzling in Odin, but I don't know how it works actually. I've never used it. Okay. Oh, you have to use the keyword swizzle. Right. And then the indices. Okay, that's a bit different to how I thought. Look at that. ZXY. Oh, it's just swapping the positions. A dot. Yeah, okay. So you can swap the positions, but you can't populate, I guess. Actually, could I do... It's expand, right? Was it expand? No. Something in the runtime. We go to the runtime here, base runtime. Look at the procedures. Oh, there's so many. I can't remember what I was even looking at before. I think it was near the bottom. Panic new. No. Was it runtime or was it intrinsics? Built in. No, it was built in. Yeah. Expand value. Okay, struct or array. Is it gonna work to multiple fields? I don't know if this is gonna work. And also it's stupid, but I just want to test it anyway. Okay. Expected 4, got 2. Damn. Wait, does that work? I don't know, it's just, this is like making your code unreadable, so it's really stupid to do. I'm not going to do that. Just going to do what I was going to do. X, camera position dot Y, camera position dot Z, and 0. That'll do. Okay, I think we got 2 vec4s now. Is it going to work? Right, this is wrong. Size of vec4 times 2. This one just works because I guess the matrices. Yeah, because they're matrices, so it's always 4. 4 by 4 floats. What's the problem with compiling? Oh, the program's running. That is the problem. Okay, well, we didn't fix the problem. I thought that was the issue. And size in bytes is size of vec4 times 2. Maybe I need to change these to vec4 or vec3 and then float. I don't know if that's going to work. Maybe. No, that's not going to work because it always expands the vec3. That's really annoying. Okay, those are the only places I need them. Okay, still got an error. What is it? The layout must match. Okay, it's not. That's not the problem. Uses the descriptor set1 binding 0 variable blah, which is a uniform buffer. Okay, but the binding flag was vertex bit. I don't know, does that sound like it's maybe a problem with SDL or with the bindings? Or maybe I just forgot to set something somewhere. Okay. Let's see if Gemini can answer this question. False positive. Yeah, this is the same error that I'm getting. Yeah. Stage, oh no. Yeah, fragment uses blah of type blah. Okay. What is this talking about? Okay. We could fix this by declaring read-only storage texture descriptors. No, this is actually a different error, I think. So we've got a... God, why are these errors so hard? Could they format them? I mean, it's great that there's so much information. It's just really hard to read. Shader module. Okay. Pipeline layout. Great. We'll create the graphics pipeline, and we're in the fragment stage. Yep. Uses uniform buffer. No, this is the type that it's supposed to be, but it's set to BK shader stage vertex bit. Okay, let's have a look at some SDL3 examples where they use potentially. No, I want the GitHub. GitHub. I was looking at this just earlier. This one? Yeah. So I need something that uses a uniform on the fragment shader as well. So I've got to search for this function, push GPU fragment uniform. Okay, this one. Animated quad. Also custom sampling, also depth sampler. So any of these should be fine. Texture animated quad, that sounds pretty simple, relatively speaking. Okay, so we're passing in a, close this. God, I didn't actually want that open, thank you. Can we just lock this? I just want to click on things, I don't want everything to... That's fine. Okay, so we got this here. Frag multiply uniform. Okay, now I do want to click on this and have a look. Okay, RGBA. Okay, that's fairly straightforward. So they just push the GPU fragment uniform data to slot 0. Okay, where are the shaders? Let's have a look. Here. So I need to look at this. Textured quad with multiply color dot frag. No, it's HLSL. Okay. I don't know what this means. So, C buffer of uniform block. I'm not going to look that up right now. Am I doing anything different here? Not in the shaders anyway. I'm just going to pass in some other data. Some arbitrary information here, I guess. Player position can be... Doesn't really matter right now. I could probably just use a single 0. Right, great, okay. That's all well and good. I think it's not really working because of this though. So what if we put in here? Actually, what is the size of a vec4? Is it packed? That could have been a problem. Fragment shitty. But that's not the problem we're having. I don't know why I keep saying that. Okay, I'm just going to put in camera position and it's going to overread. Okay, that's cool. That's fine. So the uniform buffer is working in this instance. Let's see if there's still a message. There is. Right. Is the uniform buffer working? Let me see, actually. What is this used for? Player position for the view direction. So this is only used for the reflective light, which may not be even working. So why don't we use this for the light position instead? Or as well. That would make the scene change drastically depending on the player's position. Yeah, okay. So I'm gonna guess that's all zeros, huh? What if we actually just set the color? To RGB. Whoa. Okay, I'm gonna just turn this off in case anyone has epilepsy. That looks really cool though. Definitely weird. Maybe because they're not normalized colors. No, I need to normalize each of them, not all of them. I apologize if you have, oh, yeah, I'll just delete that. Okay. So, that's interesting. These values are changing even when I'm not moving. What is going on here? Very strange. What if I set the binding to 1? Because what are we setting into the fragment shader? Model view projection. That shouldn't have been changing either though. Because we weren't moving. Something funky is going on here for sure. So I'm just going to set the slot index. Actually, we can do that in main. To 1. Oh, alright. Okay. never seen anything like this before. This is wild. I guess I need to look at this error again. God damn it. I'm gonna get a drink and turn on the aircon because I'm sweating. So, yeah, that's cool. They get names. I'm pretty sure I didn't get names in mine, right? Oops, sorry. Let's just minimize that. No, I just got null. Maybe I can do something about that. I'm not sure. Okay, I'll be right back. I'll put on this cool anime theme, see if it works. All right, I'm back. You know what using that anime theme thing is like? It's kind of like when you join a really old MMO that's sort of dying, and they give you the newbie starter pack, and then there's really powerful potions and stuff or whatever, but then there might be a cosmetic that makes you look really cool, except everyone gets it. It's kind of like that. And so it looks cool, but just because of the fact that it's not exclusive at all, it's not really interesting. That's kind of how I feel about that. Because anyone who uses stream elements gets that for free. And it does look cool, but it's not unique at all. So, what I didn't look at in the example is I didn't look at where they did the pipeline. I closed it, didn't I? Where they created the pipeline. So if we go back to SDL3 examples, GitHub, and we look at this guy, the spy dog. Get a few things in here. Oh, my computer's freezing. I gotta close those Vulkan tabs. They'll get you. They'll get you. 64 gigabytes of RAM, and I can't handle the Vulkan tabs. And these are the people that are making the cutting edge graphics APIs, huh? I'm skeptical, let's say. I'm sure they're different teams. So, textured animated quad, that's what we're looking at, right? Or was it just animated quad? I think it was textured animated quad. Yeah. So I didn't actually look at the pipeline create info here, but they've got, yeah, vertex buffers, 1, vertex attributes. That's all good. I've done all that. Vertex element, blah, blah, blah. Create the pipeline. Okay. What is the difference? What is the difference? Actually, I don't see the uniform in the shader creation. Where is it? Oh, they've got this abstraction here called load shader. So I've got to look at that. Okay. So we're making a fragment shader. That's good. Number of uniform buffers is uniform buffer count, which comes from here. Okay. Uniform buffer count is 1. Storage buffer count is also, oh no, it's sampler count. Sampler count, uniform buffer count. Okay. Stage. Yeah, I'm pretty sure I have all that stuff set correctly. I mean, obviously something's wrong, but... Okay. Alright, so... Stage, fragment, formats, BOV, entry point, main. Code size, entry point, format, stage, number of uniform buffers is 1. I don't have a sampler because I don't have textures yet. They don't use any storage buffers, and they don't use any storage textures, so... What the hell is the difference? So vertex buffers 1, vertex attributes 2. I don't think that is going to have anything to do with this. Is there some kind of internal state maybe? Like for example, does SDL3 do something? I don't think, well, I guess we could look at it. Huh. So when we get to the end of our pipeline, we release the GPU shader. Is that incorrect? Because we've compiled them into the pipeline. No, they do the same thing. Create the graphics pipeline, release the shaders. You know what? It could be a problem with the... No, it's with the uniform function. Vertex uniform push versus fragment uniform push. Is there a difference that I'm not considering here? They use the same command buffer. In this case, yeah, they use whatever slot index you pass in. The data's a raw. No, there's no difference between these. I mean, in my code, there's no difference, and in their code, push. Push GPU fragment uniform. Okay, use the same command buffer as the vertex, yeah. 0, great, and then they just have a struct right in here. Fine. Okay, I'm not understanding why there's a problem. This is crazy. So you've got to bind the vertex buffers, bind the index buffers, bind the fragment samplers, but you don't have to bind the uniform buffers. That's right. Okay. Vertex attribute, location 1, yeah, alright. Well, I don't know what I'm going to do if I can't figure out this problem, because this is definitely wrong. And it only happens when I use these uniform values here. Even if I normalize them, which should make them between the value of 0 and 1, I still get those crazy results. Which tells me something is going horribly wrong here. I'll set the binding back to 0, go back to main. Okay, I'm going to send in just position plus, oh yeah, I can't compile when everything is open. Oh god. Is a render doc going to tell me anything? Alright, so I've got the color pass, drawing the stuff. Let's see, fragment shader. Okay. Apparently the fragment shader doesn't have any bindings. Did I remove that when I made the pipeline? What is it called? Render pipeline. No, it's here. What if I just give it a sampler anyway? What is that going to do? It's going to crash the program because descriptor sets are wrong. So this is what I'm confused about. The VK descriptor set layout binding stage flags was VK shader stage vertex bit, which is telling me that somehow the fragment stage descriptor is using the vertex bit flag. Alright, I'm going to try something a little bit desperate. I'm going to stash these changes. I'm going to pull the latest SDL3 bindings from Odin. And what has been happened? What has been happened? What has happened? They've been doing a bunch of stuff. See, I was only using SDL GPU, SDL3 GPU, so I thought it would be fine. That was ages ago, so February 4th. That was 4 days ago. I'm pretty sure I only downloaded this a few days ago, but anyway. It comes with a lib, so if I try to compile this, right, LVA required uniform buffer object can't modify uniform. What is going on here? Build shaders. No, that's the wrong directory. Okay. That's good. Can't modify a uniform. L value required. I don't understand. What's wrong with this? No, it's this. Oh, right, we can't modify the uniform, of course. So, was that an error this whole time? Bloody hell. See, this is why I need to get a better build system. Not a build system like CMake or something. But something like, imagine you've got this window here on the left. You press build and then it just says, has all the build info in here, and you can scroll up and down. I suppose I could just open a new tab. Wait, how do we do that? Split tab. Or is it this tab I want to split? I'll split this tab. There we go. Can I swap them? I really want it to be on the other side. I guess I can just close this. And the hotkeys, I don't know hotkey. Okay, Alt and left and right. Hello, Yingbo, how you doing? Huh, that's weird. Oh no, I guess I just updated the bindings, so this is different now. Okay. Oh, that's not good, still. Because I didn't actually put these values in here. Red, green, blue. Okay, we've just got darkness. How do I like Odin? Odin is good. I don't have any complaints. It's very predictable. Yeah, I don't really know what to say negatively. I don't have any criticisms right now. I think that there was one thing that I wish they had, but I can't remember what it is. Yeah, it's all very straightforward. Kind of like Go in that respect. But it's got some nicer features than Go, I would say. Okay, let's have a look at the... Yeah, that's all good. I got the mesh, but I don't want the mesh. I want the fragment shader. It's red. Why? Okay, it looks like at no point does... Oh, because it's selected, right. At no point does it have a uniform buffer, which is just great. Does Odin handle errors using sum types? You can, if you want to, but most of the time the format is more like this. Where would we see something? Oh, I have an idea. So the format's more like this here. Read entire file from file name, and you get back two values. So one's going to be the data that you get back, or it'll be an empty slice if you get back nothing. And the other is going to be whether it succeeded or failed. So then you would do something like data okay, read this file, if not okay, panic, could not read file, or something like this. You could also do, you can join these together, so you can sort of do this. If okay, and then do something with data, and data is scoped to this scope here. Yeah, although I think Bill would have something to say about that, where Go uses fake tuples or fake multiple return values which are actually tuples, and Odin has real multiple return values. I don't fully understand what he means by that. What was I looking at? This. There's no uniform buffer here. It doesn't force you to check for errors during compile time. I mean, I guess. You can just skip them if you want to. So this is working fine. This is still not working. Great. I'll call it something else. I'm pretty sure the name doesn't matter. Build. Okay, fragment shader. Still no uniform. Okay. Gonna have to solve this particular error here. It's got to be somewhere in this that I've messed up. I just don't see how. Set the stage correctly. The number of uniform buffers. Fragment shader. That looks fine. I hate being stuck on a problem like this. I guess I could do something else. Hey, why is it black? Oh, because of this? Oh no, it's because of this light position and player position. We don't have a position right now because the uniform doesn't work. Wow, that's a very bright light going that way. Interesting. That looks kind of wrong. Okay, I messed something up in the shader here. Frag position is coming in. We don't need to normalize the normal again. That looks all the same. Not sure. Oh, I know why. It's because I set the player position to here. So it's really reflecting bright that way. I gotcha. It's because this wasn't working previously. So I'm actually just going to make the specular. I'm going to turn it off right now. Since we can't pass the player position in anyway. Okay, there we go. Now, there is an option of passing more data into the vertex uniform buffer because it seems to actually work. And then passing that into the fragment shader. That seems like a weird thing to do though, because you pass it in for every vertex when you only need it once. And I guess for every fragment, actually. Maybe that could be a hack until I figure out what the problem is with the uniform. So I just put this in here, vec3 player position, and oh wait, no, I can't pass them in like this, can I? Yeah, I can. Player position and light position. So I'll just hard code it in the vertex shader for now to make sure it works. So this is going to be the player position out. I really should prefix these properly. Okay. Apparently that compiled. Now we need to actually send the data in though, which is going to be here, vec3. So this is going to get turned into a vec4. I think. Yeah, 4x4, 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 4, 4. Yeah. Okay, MVP. I'm going to change this to also have player position, light position. Alright, we'll just hack that together, that's fine. We'll modify this other variable. That's fine. So we're going to say, actually, MVP.light position. Actually, we'll just do it like this. Okay, and then MVP.player position is camera position. Oh yeah, I could actually do it like this. Because these are vec4s. Wait, actually I should add the comma, then paste twice. Okay. Oops. Okay, I think we are good. Alright, yeah, I thought that might happen. Oh no, that's working correctly. Okay. So, I don't know how much overhead that's adding to the shaders, passing this from the vertex shader to the fragment shader. But until I can figure out why the uniform buffer on the fragment shader isn't working, I guess this will do. So I've got a moving light going back and forth. That's cool. Cool. And then if we also move on the x-axis, what does that give us? It's kind of hard to see. I think it's going around in a circle. So I guess that point is 0, 0. I should probably add text rendering, hey. Yeah. Okay, that's working. Excelente. Definitely not how I would prefer to do it, but that's okay. Okay, cool. We've successfully avoided the problem. Let me sit back up. I was sliding off my chair. Did my AC turn off? Or did I forget to turn it on? Maybe I forgot to turn it on. Sometimes it just turns off though. Because when the people built this building, they decided that all of the people using the air conditioning would be unlikely, or some number, I guess, would be unlikely. So the circuits get overloaded all the time, and the AC breaks, and then people have to come and fix it. I can't imagine if I actually owned this apartment and I had to pay, I think it's called strata, and you have to pay for the repairs and stuff. It'd be pretty annoying. Although renting does suck. Especially right now. Alright, I'm pretty happy with this at the moment. Have I tried turning it off and back on? I have tried that. Yeah, definitely tried that. It seems to be working for the moment. We'll see if it turns off again. Alright, we got the rotating light, that's good. Huh? Am I renting? I feel like the chat is delayed or something. Because I just said I was renting. Yeah, I am. I was gonna build a house a few years ago. And bought the land, and then we went to start the build. And someone started building on the lot next to my lot a few weeks earlier than I was going to start. And because of the laws or the regulations, I couldn't build the build that I had planned and worked out with the builders, because they were building a 1-story house and I wanted to build a 2-story house, and I was to the north of them, which means I'd be blocking the sunlight for most of the day, and that's not allowed. So I ended up just selling the land. And yeah, a bunch of other stuff happened in between then and now. Now I can't afford land anymore. The prices have gone crazy. Like for example, I know someone, I'm not going to say who it is, not that you would know, but anyway, I know someone who bought some land with a little church on it, maybe 5-6 years ago, something like that, and it's gone up by 500% in price, something like that, some crazy amount. Alright, so I've got a rotating light. I don't know what I was going to do next. Oh yeah, I was following this sort of OpenGL lighting stuff. How big is the house so it would block the sun for the other building? It was just a normal 2-story house. It wasn't big. But the problem is, because of the angle, it would be blocking their sun for like half the day or something. Okay, materials. I don't care about materials right now. What else we got? It's a lighting map. Lighting map is what? What does it look like in the end? Oh, this is... Right. Okay. So part of it is going to be more specular than the other part. Oh, that reminds me. I could turn the specular back on, because the movement is now working properly. So if I look, yeah. Okay. Wow, that's really bright. Let's make it do a different rotation, eh? What about something like rotating on just the Y and the Z axis? Is cosine gonna work for this? Cosine. I think so. And then oh, where did we go? Yeah, that's kind of cool. So we sort of got a really fast day-night cycle with a really red sun. Excellent. Actually, the light's white, isn't it? It's just this material is red. Alright, I'm not going to go into materials yet. Let's look at, what is a light caster? Oh yeah, this is kind of what I want to get into next actually. So we can have a directional light for the sun. Probably just going like in an arc. And then coming back later. And then we can have point lights, I guess. Is that what they're going to set up here? Yep. Cool. Alright. Let's see if we can get this stuff in there. Our current light looks like a spotlight because of how bright this specularity is. But that's alright. So, a light source that casts light upon objects is called a light caster. I mean, I would have just called it a light, but I guess that makes sense. So a directional light is a directional light caster. Or is it... Who cares? I don't know why I'm even bothering. Okay, so... We're gonna just pretend it's infinitely far away, right? Yeah, good. So all the light rays are parallel. You can model such a directional light by defining a light direction vector instead of a position vector. The shader calculations remain mostly the same, except this time we directly use the light's direction vector instead of calculating the light direction using the position. Okay, that makes sense. So we're going to need a struct in our shader that has these lighting properties: direction, ambient, diffuse, specular. Okay, very well. People generally prefer to specify directional light as a global direction pointing from the light source. I suppose. Okay, to demonstrate that directional light has the same effect on multiple objects, we revisit the container party scene. Container party. That's great. From the end of the coordinates systems chapter. Great. Yeah. So there's 10 containers having a party. That's all good. Gotta set the light direction. Yeah, okay. Alright. Oops. So... Right. It looks like there's a sun-like source casting light on all the objects. Right, okay. So because we don't have diffuse and specular components of our object right now, it's probably going to be shiny. Let's have a look at the source. I just want to look at the fragment shader, I think. Oh, interesting. There's light cube and light casters. So these are different shaders. So what's the lighting shader? What is that? Okay, and what's the light cube shader? Oh, it's commented out. Okay. Interesting. Okay. Sure, it would be nice to be able to use uniforms. Gonna have to pass them in for the vertex shader. Oh well. I just didn't want to rat hole on that too much in a stream, although this stream today is gonna be super long. It's only been 2 hours. Probably gonna be here for another like 4 hours or something. It's my only day, I guess, that I can do this for the next foreseeable future. I just finished a coffee, but I feel like another one. Alright, let's see if we can implement this, eh? So we got a light. We just have one light, I guess, in this case. Alright, in that case, all we really need to do is pass in the direction. Everything else is pretty much the same, right? Yeah. Okay, since we're not using materials yet, it's all pretty much the same as before. Actually, it's exactly the same. Although this is not being multiplied by the light color. I guess the light color would be or just white in this case, I guess. Well, let's have a look at our fragment shader, right? So the only real difference is the light direction is not based on the light position, it's just based on a constant angle. Well, not technically not constant, but because it could be passed in as anything via the uniform. But in this example, I think it is just constant, right? Where is it? Here we go. Negative 0.2, negative 1, negative 0.3. So if we actually just set this to that, we'll get basically the same result. And it looks like it's not being normalized, or is it being normalized here? No? Well, it's not just a direction if it's not normalized, right? Where's light direction? Here. Okay. Ah, here, it's normalized right here. Okay, gotcha. Okay, cool. So we're just going to say negative light direction. And light direction is going to be something that we pass in. But I'm just going to hard code it to the values that they used for testing. Negative 0.2, negative 1, and what was the other one? Negative 0.3. Okay, great. Cool. I think that looks... Whoa. Whoa, if I look over there, it's really... Jesus. Is there something up with my specular here? Specular strength is just too crazy or what? Let's have a look. Okay, so we've got specular is based on the view direction, the reflect direction, which is based on the light direction, which is this light direction. And I know we're copying a lot of variables, but whatever. Okay. Diffuse. Yeah, that looks fine. We don't have textures, so that's fine. View direction, reflect direction, yeah, blah, blah, blah. Okay. I don't know, I feel like maybe this is just too high for specular strength. Wow, that's still really bright. So the sun is up there, I guess. Wait. Is it? It's kind of hard to say. That's such a weird effect. So from this side, it looks like this. And then from this side, it looks super bright. Doesn't make any sense. Yeah, probably because this is way too simple of a model. But that's alright. So we've got ambient, normal. I don't think we already normalized the normals, but I'm going to normalize them again just in case. Because we're using them to do calculations, right? Normal. Wait, what? So we use them in the reflection and in the diffuse. Pretty sure that is not going to make a difference. Oh, it totally does. So they weren't normalized? I thought we normalized them. Shit. Okay. Interesting. Okay, yeah, that's kind of more what I was expecting. Alright, so the problem was our normalized values, which I thought were normalized, but actually weren't, were going crazy. Oh, because I deleted it. I'm stupid. When I was copying the normals, here, I had vertex.normal equals normalize vertex.normal, but I deleted it for some reason. So yeah, silly. I don't know which one is going to be faster, whether on the GPU or the CPU. Usually GPU is faster, I think, but it depends on the operations, right? So that should be the same now. Yeah, much nicer. So we got a nice subtle specular lighting effect. That's better. And the sun is definitely over there. Well, I guess it's directional, right? So sun's reflection is that way. Got some nice bleeding because there's no such thing as occlusion yet. Good. Okay, I'm kind of happy with that. Sunlight. I want to make spotlights now. Wait, what is this? Ah, okay. So this is sort of a... How do you want to set your lights? Okay. It is simply a question of experience and a moderate amount of tweaking. Well, that's good. That makes it better for me. In our environment, a distance of 32 to 100 is generally enough for most lights. Okay. Wait a second. Attenuation, reducing the intensity of light over distance. Yeah, okay. So I didn't actually read this part. So, luckily some smart people have made a formula that I need to figure out. So, F, attenuation. What is F? Factor? Well, anyway, this is what we're solving for, apparently, and it's 1 divided by K, I think this is called sub, right? K sub C plus K sub L times D plus K sub Q times D squared. Okay, what is this? Distance, this is the distance. Attenuation, constant term k. Oh, okay, I see. Constant term k sub c, linear term k sub l, and quadratic term k sub q. I have a bone to pick with mathematicians as to why. I'm sure there's a good answer, but why do these have the capital letter K with a sub letter when they could just be this letter, CLQ? Maybe I'm just thinking too much like a programmer. So the constant term is usually kept at 1. Okay, the linear term is multiplied with the distance value that reduces the intensity in a linear fashion. That makes sense. The quadratic term is multiplied with the quadrant of the, yeah, okay, gotcha. Quadratic term would be less significant compared to linear term when the distance is small, but much larger as the distance grows. Okay, so as the distance gets further away, the intensity drops down in this kind of slope. Okay, that's cool. Yeah. I think you could get this slope in a much easier way, couldn't you? But anyway, whatever. I'm not the guys who invented this lighting technique, so I have no idea. Okay, good. So this is, it reaches 0. Oh, it actually reaches 0, so it's not, what's that word? You know the word where it's gonna reach 0, or it looks like it's gonna reach 0, but it never does. It just keeps going to infinity. Man. Asymptote? Yeah, it's not an asymptote. That's right. So it actually goes from 1 to 0 in this slope. Cool. Right. Because k underscore k whatever is an indexed set that represents a polynomial, that represents polynomial coefficients. Says Yingbo Ma. Okay. Right. I need to learn polynomials. I've got a lot of math to catch up on. I just kind of go by vibes. It's not really a good way to do it. Right, okay. In our environment, a distance of 32 to 100 is generally enough. Gotcha. So, to implement attenuation, we need 3 extra values in the fragment shader. Thanks for answering that question, by the way. I knew there was going to be a reason that made sense. But it's just when I'm reading formulas, I always feel like it could be simpler. Maybe because I'm just used to reading programming instead. These are best stored in the light struct we defined earlier. Okay, so this is going to be a point light. Okay, so let's make a, yeah, we'll make a separate point light. So we'll have the sunlight, which we'll just leave as is, I suppose. What are we not using in here? We're using light direction, using light color, using frag color. That's just like a, oh yeah, I set that to a constant value, but this could also be the normal. That might look kind of interesting. Yeah, it definitely looks more vibrant, I'd say. But yeah, not great. I think I prefer the darker version. But I'm gonna make it, I don't know why I'm stressing about the colors again. What about that color? That is not a good color. I'm just going to make it gray. Nice and bland. Good. So I actually wanted to rename these to be sunlight direction. That can go here. I'm going to call this sunlight specular strength. Actually, I'm going to, before I do that, I will search the, hey, light direction. Yeah, what the hell? Okay, there we go. Sunlight direction, very good. Light color, sunlight color, and specular strength. Whoops. Sunlight specular strength. Okay. Actually, this doesn't really make sense because it's the material that has the specular strength, not the light itself. Yeah. That's fine. I'm just going to add a single point light. And I'm going to change the sunlight color to have a little bit less blue. Let's see what that looks like. Yeah, well, the whole world is grey, so, you know. Suppose it's a little bit nicer. It's less nice, it looks kind of sickly. Oh well. So we want basically these components. Position, ambient, diffuse, specular again, constant, linear, quadratic. So I'm just going to copy these. Actually, I'll just copy this struct. Why not? Okay. Interesting. What? How can you just set a float like that? I'm gonna have to look at the code. Let's see, where is it? It's probably a shader. Yeah, there we go. Set float. Oh, okay, it's just one of these. GL set uniform, yeah, blah, blah, blah. All right, well, I don't have that exact functionality. So I will just pass the values in, or I will actually just set them in the code directly. Light equals position. I'm not sure about the format of this. I'm just gonna declare it like this, I guess. I don't think I can assign a value here, can I? Maybe I can. Light dot. I'm gonna leave position alone. Constant equals 1. Linear equals 0.09. Quadratic equals 0.032. Okay. So we've still got to calculate the ambient, diffuse, and specular of this light and give it a position. Position equals We'll put it at 0, 1, 0. So it'll be in the middle. No, it's not going to be in the middle. Let's think about this. This one of these corners is 0. I think it might be this one. Wait, actually no. This must be 0 because I never set the player spawn position, did I? Pretty sure I didn't. Camera is... Okay, so I am set to this position. No, my position is just 0. Okay, so this model is actually in the middle of the world. Okay, that's good. Okay, cool. Alright, back to the fragment shader. Alright, let's see. So implementing attenuation is relatively straightforward. We calculate an attenuation value based on the equation and multiply this with the ambient, diffuse, and specular components. Right, so we have to have those components first, which I guess would be the same as these. Yeah. So we need to subtract the position from the player's position to get the direction, but everything else should be the same. Alright, let's have a look. Light dot... Oh, hang on a second. So we want to do, what is it? No, not sunlight, what am I doing? Light position minus player position. And then we want to do reflect. We already got the view direction because it doesn't change from this. So we can get the reflect point light. Reflect direction. Obviously, I'm gonna have to change all this code later, but I just want to see if we can get some stuff working here. We'll pass in the normal, and then specular is gonna be based on this reflect direction. So I guess we can just copy this. Same with the diffuse. Point, oops. This is going to be the point light view direction and the point light reflect direction. The specular strength is just going to be the same, I guess. Point light spec. And this is going to be point, I think it has a, does it have color? No, they don't have a color. They probably should have a color. So I'm going to add that. Let's make it green. Okay, and point light diff is going to be norm and point light direction. Point light diffuse, light color. Fantastic. So I guess we will just put this up here for now, and we're going to make a new one. We don't have an ambient. I'm going to put the ambient strength up here. Okay, very good. Now we want to make a results, but we already have one, so I'm just going to rename it. Okay, point light ambient plus diffuse plus point light specular times frag color. Did we get a compile? No. What is happening here? Build shaders. Alright, line 30, unexpected identifier. Did I forget a semicolon? Oh yeah, we can't do this. Okay, that's fine. Is this allowed? Point light view dear, undeclared identifier. Oh yeah, that's not a thing. It's just view direction. And the other thing was dot no matching overloader function found. That's probably because that was undefined. Okay. Alright. Hey, okay. Interesting. So we can only see inside the light, which I guess makes sense. So we're inside this light here. You can see some stuff around. It gets darker as it goes further away, looks like. Okay. Yeah. I like that. That's cool. Cannot see from outside. Maybe it's in the ground. Where did I set the position to? It was 0, 1, 0, right? Yeah. So we're not even doing the attenuation yet, and still we can't see very far. Did I mess something up here? There's something I wanted to look at. Is this correct? Point light direction. Does a point light even have a direction? Now that I think about it. It's supposed to be spherical, right? But it would still be based on the player observing the light. It's just a bit weird that I can only see when I'm standing inside here. Did I mess this up? Is that the right way? I think that's the right way. Play position minus light. Yeah, that doesn't seem right. Yeah, that's definitely... Yeah, that's wrong. I'm pretty sure. Yeah. Interesting. Like even with just a little bit of ambient, I would have expected to be able to see something, right? So if I comment out this, actually I don't know if you can do these comments, can you? Apparently yes. So it's just green, because nothing's being multiplied by the normals, I guess. So that's why you need the diffuse. No, no, is that wrong? Yo, what is that? How did that get there? Right, is that what happened? I accidentally inserted something, broke the compilation. Yeah, okay. Whoa. Huh. Alright, well, anyway, regardless, let's have a look. If we can do something like... I want to also add these to this. Wait, that's not what I want. Can I just add them? That seems a bit weird. I'll try it anyway. Alright. So the sunlight's working, but this light only works when I'm standing in it. What? I messed something up. Definitely. Let's see. So point lights. Okay, please show me the code at this position. Bump. And I want the fragment shader for the light casters. So the light direction is the light position minus the fragment position. That could be my problem. Is that the correct name? Yeah. Okay, yeah, that was the problem. That explains it, actually. Okay, cool. So we got a point light in there. Looks kind of cool, actually. Doesn't care about nothing. Just lighten it up. That's cool. Huh. Man, this is such a cool area of programming that I've never really messed around with. Graphics programming, I mean. I have a feeling that in a year or so, I'm going to be way better. And it's going to be awesome. Because, you know, when you're trying to show people stuff, whether it's making YouTube videos or selling a game or anything, if you don't show something that looks eye-catching, then people just don't give a crap. Unless they're already really technical people. And if you say like, hey, this insert jargon here is what I'm doing, then people will understand and they'll be like, oh, okay, this is cool, I'm going to check this out. But if they're not, then they won't care. It's kind of how I think if you're learning to program games, at the beginning, you really need to get a rectangle or something on the screen and moving around as quickly as possible. Otherwise, the students will just lose motivation. And It makes sense because you're not seeing any results for a long time. It's kind of weird just adding these lights together and multiplying them by this value. Doesn't that make everything too bright? I would think so. What if I normalize this value? Is that gonna be weird? Cool. It's not correct, I don't think. Or it could just be too dark to tell. It's kind of interesting though. Although I guess light is kind of additive, isn't it? If you keep adding more lights, it just keeps getting brighter until it's blinding. Cool. All right, I'm pretty happy with this. We've got sunlight, we've got a point light, which we haven't got any uniform values for yet. So that's all right. What is next? Multiple lights. Well, that is definitely a thing we could do. Some function to calculate directional light. So you just add to this output vector, that makes sense. Some function to calculate point light. Some function to calculate spotlight, okay. That's pretty cool. So directional light. Point light. I don't understand why there's no color. Maybe they just didn't want to go into color yet. Okay, interesting, interesting. Yeah, cool. So we basically have this now, except we don't have flashlights. This is interesting. Play around with the values, get some different looks. Horror, factory, biomechanical lab. Ours kind of looks like this one right now. Yeah, it's green. Looks all dusty or smoky. Yeah, it's kind of interesting. Yeah, so I kind of want to look into shadows, which I'm going to guess is somewhere in advanced lighting. What have they got? They've got shadow mapping and point shadows. So, So did you guys know that one of my friends told me this recently? Fallout 3 has no shadows. I thought that was crazy. Let's see if I can find something here. Fallout 3, YouTube. Do I dare look at YouTube? Yeah. Okay, this is probably a cool video, but I don't really want to look at the video. I just want to show you this frame here. Right, so you can see there's ambient occlusion, the dark spots. There's reflections or specular highlights, but there's no shadows. It's kind of crazy. I didn't even notice when I played the game that there was no shadows, which is kind of interesting. Okay, so I know a bit about this kind of stuff from doing collision detection. So hopefully that comes in useful here. like, you know, drawing rays and figuring out if it's hitting things. Of course, in this case, we've got rotated objects and different models, so we're going to have to do something a bit different to what I'm used to doing. I wonder what they use. The depth testing. No, we didn't go over depth testing yet. So Z distance stored in texture depth map. Okay. Gotcha. Okay, so they make a depth map. Interesting. Yeah, I wanted to learn about depth maps actually. Second render pass should give you results similar to the image below. Right. Okay, interesting. Shadow acne. Right, I see. Huh. Interesting. That's what that is. I always wondered why there was the jagged edges around shadows. It's because of the way the depth map is calculated. Huh. Right. Peter Panning. Yeah, right. Why is it called that? You don't want to grow up? That doesn't make sense. Because it's flying? Looks like it's flying. That's why. Okay. Without culling. With culling. Oh, interesting. So we need a second render pass. And the render pass, the shadows, is gonna cull front faces from our point of view. Okay, yeah, that makes sense. But only for solid objects. Right. Well, this is a bit of a mission, but gotta start somewhere, right? Percentage closer filtering. Okay. Well, first I'm gonna make the lighting a bit easier to use before I jump into shadows, I think. Oh, Peter Pan lost his shadow. It has nothing to do with hovering. Interesting. Okay, thank you, Hermes Mercurio. That's a cool name. Hermes Mercurio? Is that real? I don't know. Seems like a fake name, but if it's a real name, awesome. All right. All right, I'm gonna have a short break to grab another coffee and go to the bathroom, and then I'm gonna fix this shader as much as I can, make it a little bit nicer to work with, so we can add multiple point lights. I have a feeling this is not the way we're going to be doing lights later, but I don't know better ways yet, so yeah, that's fine for now. Sunlight. I also want to look into raycasting a little bit. or ray tracing rather. But I don't want to go there just yet. So we'll use the old school methods. See if we can get something nice looking. Maybe I never even have to look into ray tracing, although I want to just for the fun of it. It sounds pretty cool. But yeah. Alright, I will be right back. Okay, I'm back. Couple of things. First thing, my air conditioner is turning off by itself. Really annoying. So I started sweating again without noticing. Second thing, I've been wearing these headphones the whole stream, and I've been playing nothing. So I'm just going to take them off. It's 3 hours of compressing my ears for no reason. Although they were noise cancelling, which is kind of nice. And last thing is, I think what I'm going to do is I'm going to commit this code, and then I'm going to try to rewrite the sunlight from scratch and see if I understand. So let's do that. Good. Let's have a look at the status. We've got a bunch of stuff. Oh, that's a bunch of stuff that changed. Oh god. I'm gonna say diff on the source. So we got GLTF loader. That's fine. And added some up and down movement. And depth buffer. Okay. And index drawing. Okay. GLTF loading, depth buffer, vertical movement, simple lighting, and I think there was something else, but that'll do. All right. So now I'm going to go into that fragment shader. Yep, I'm gonna just comment out all of this. I need to tighten my keyboard. It's kind of annoying actually. Just gonna move all this down so I can't see it. Yeah, sure. Turn back 4 frag color. There is no frag color. It's called normal. So we're gonna get just. That's strange. I guess it didn't compile because return. Oh yeah, I can't return nothing. It's an out parameter, not. I mean, it's an out. What are these called? They're not called out parameters. Maybe they are. Okay. Alright, so back to normals, which is fine. I'm pretty sure I was in the middle of saying something, but I don't think it was that important. That coffee is hot. I just burned my mouth a little bit. Nice. Oh yeah, my keyboard. It's this, I don't know if I can lift it up in front of the camera. Called the Moonlander. And I kind of like it, but it's got these little bits, if you can kind of see here, there's sort of this Allen key part, and when you press too hard, this little thing moves up, and then it becomes rickety like this, or it becomes sort of depressed, and so I've got to keep tightening them all the time, which is not really what you want from a keyboard, to have to pull out an Allen key and tighten it every now and then. Okay. Alright, so we're going to see if we can do the sunlight without looking it up again. well, as much as possible. So let's think about this. We got to get the direction that we're looking at the particular pixel from, which is going to be our look direction or something. So look direction is going to be the normalized. It'll be the player position minus. Will it be the player position minus the frag position? No, the other way. I think. Okay. Now we've got a direction. How can we verify this? Let's say we make a what is that thing called? Dot product. So I'm just going to make a dot product called lookingness. Doesn't make sense, but that's fine. And we're going to do dot product of the look direction and the sunlight direction, which we don't have because we need to make that sunlight. And I'm going to say this is going to be, but we don't want it to be the actual sunlight direction. We want it to be the reflected sunlight direction. So we're going to reflect, I think, or we reflect the look direction. I guess either one is fine, right? So this is something like, I already remember what it was actually, which is kind of cheating because I just remembered it, but it's so straight down and then sort of angled. Okay, and then how can we represent lookingness? I want to set one of these components maybe. RG, and then B can be normalized lookingness. What is that going to do? Should give us a interesting result here. Wow. Okay. So it's our position minus, what was it again? The frag position minus the player position. Okay, interesting. The sunlight direction is not normalized. Should be, right? It's not closed. Okay, we've got to open it again. All right, so that just gives us a sort of more vibrant situation. So there's definitely a plane or some kind of vector shooting down through the player. In fact, maybe I should not put the player position and I'll just put 0. That doesn't make sense though. Can't put 0, 0, 0, can I? Because then the look direction is going to be, yeah, just pointing towards 0. Interesting result. Okay, I think I need to use a drawing. Okay, let's use a drawing here. Okay, so we've got, I'm just going to use a flat plane here. Let's just say this is our surface that we're drawing the fragment of. Okay, we've got our eye, which also looks kind of like a sun, I guess. So I'll put a little thing in here to make it look like an eye somehow. Okay, that's a really wonky eye. Gross. Okay, why don't we do it like this? It's usually like this, right? And then a little arc. Hang on a second. This is irking me. Okay, this was way too. This took way too long for no reason. There we go. Let's move this up here. It's a bit jank, but that'll do. Okay, so we got our eye. After all that effort, I'll group this together. Make this white, I guess, or something. The ground is also going to be this light yellow color for some reason. Okay, and we're looking down at the floor. And we've got a sun up here. Okay, the sun is shooting a ray. Well, it's shooting lots of rays in all directions, but let's just say, for the sake of us, we kind of need the reflected angle from the sun to be going straight into our eye. That way, when we look at this pixel, we actually use the light from the sun to color the pixel. That's all we need. Okay. So we need this direction here, which is... Yeah, interestingly, the sun is coming at a constant direction, though. The way that we've programmed it. So the sun direction is sort of like this, as they had in the OpenGL book that we were just looking at. And so I suppose at some point the reflected angle of this, if we just reflect this, can we flip this horizontally or something? Yeah. And then maybe vertically and then horizontally again. So this is going to come back up into the eye. Right, okay. Let's just do that, that's fine. But the thing I'm kind of confused about here is, well, the color for this plane is going to be determined by this. But then what about these pixels? Because we can still see them. If we imagine the eye can see sort of, you know, this whole area. We still need to color all these things because they're visible. Yeah, I obviously didn't understand some part of this, so let's have a look. Lookingness. What I was thinking was, with this lookingness idea, was if we have a... where is it? Frag position minus, well, I was going to do the player position, right? So the player's here, the fragment's here. let's say the world is starting here, I suppose. So the player position is here, minus the fragment that we're looking at, whichever one it is going to give us, what is it going to give us? So this minus this, it's going to put us over minus that. It's going to put the player like over here, right? Okay. Which then gives us this angle, essentially. Okay, that's what this is for. And then we determine how close this angle is to the sunlight direction using the lookingness, right? That's what the dot product is for. And so since that's going all the way down here, oh, we should probably max it at 0. Yeah, right, so we're looking straight down, therefore, whoa, interesting. What is this coming from? Is it from this? This angle here? Did I mess up the look direction? I don't think I did. Oh, I did. It's the frag play position minus frag position, not the other way around. Alright, well, let's just flip those, which I guess I should have expected. Okay. So the thing is, I guess we're not actually taking the look direction into account, just the position. Right? So there's the player position. There's no look direction. But we didn't use that in the previous version. Okay, I'm going to look at it. Screw it. Play position minus frag position. Oh, yeah, right. So this is the direction to the particular fragment on the screen. So we get that by default. It doesn't matter where the camera's looking, because we can see the fragments, therefore we can calculate the direction to the fragments. And a fragment is a pixel, by the way. For the maybe one person who's watching this that doesn't know that. Just because I'm sure anyone who's gotten this far into a stream like this probably already knows this stuff. Anyhow. Okay, so we got this. Well, actually we got the inverse. We got this, right? Is that correct? Normalized player position minus frag position. So we got a max dot product of the look direction and the sunlight direction. Okay, do I need to reverse this? It's just going to give me the reverse that we already had before. Yeah, okay. Obviously using lookingness as the blue component is not giving me a visual result that I can use that well. So I'm not actually multiplying anything by the fragment color, which I guess we don't have because I deleted it. But let's say the model color is going to be 0.2, 0.2, 0.2, and then we say out color is well, first I'll use the model color itself. But that's going to give us a fully gray thing with no normals, and then we won't be able to see anything. Yeah. We can only see stuff that's against the sky. So interesting. How do we actually solve that problem itself? Do we do model color? Blend them, I guess. We don't multiply them, right? And we could multiply them, actually. I think we could multiply them. Times normal. What does that give us? Yeah, okay. Sort of a muted scene. Okay. Yeah, I guess it's kind of weird the way lighting works in games. It's hard for me to wrap my head around because we're sort of calculating what color a pixel should be on the screen based on what lights there are in the scene. Which is just a weird way to think about stuff, I think. You're not thinking like, oh, the model is this color and there's a lot of brightness, therefore we should add to it or something. I'm not sure what I'm saying actually right now. It just seems a bit weird. Alright, so we got lookingness, but we're not using that. We're not using that any longer. No longer. What happens if I do this? Lookingness, I'm going to normalize it. It should be normalized already, actually. Don't need to normalize it. Between 0 and 1. Huh. Wait. What? Is there no blending turned on? I'm pretty sure I turned on blending. Okay, apparently not. So, okay, that just doesn't work. Well, that's fine, I guess. Alright, so, where was I back? Where was I at? Okay, so we got this angle here, which is our look direction. Player position minus frag position. So we're calculating this fragment. Well, that's what I've decided we're calculating. Okay, so we got this angle, and then we got this dot product between these two angles, which means I got to make the brightness, I guess, of the light affecting this pixel based on the reflected vector. So in this case, it's going to be very bright, but in this case over here, the reflected vector is going to be at a totally different angle, or a very different angle rather. If we flip it vertically, you can see there's quite a lot of space in between. So we'll get a darker pixel, I think. So this would be kind of like brightness. I don't know, it's not called that. I can't remember what they called it now, but maybe diffuse. So then we got simply model color times normal times brightness. Is it going to work? All right, that is very strange. I think that might be a little bit dark over there. and it's very bright up there. But when I'm looking down from here, that doesn't make sense. So one of these is wrong. I didn't reflect the direction. Okay. Reflected direction is going to be reflect. And then if I remember correctly, it's minus look direction, which is a bit strange. Okay, that's still wrong. Did that not compile? I have a feeling it didn't. Yeah. Can I convert float to a vec3 on line 15? What's the problem? Oh, is reflect not for a vector? I don't actually know. Let's have a look. GLSL reflect. Calculate the reflection direction for an incident vector. Yeah. Okay, we could do this. Incident vector minus 2 times dot product of the normal. Oh yeah, we didn't use the normal. I think we missed a parameter here, perhaps. You can't just reflect something off of nothing. That makes sense. Alright, we got some interesting results here. As I look towards 0, it looks like I'm getting brightness, and as I look away, I'm getting complete darkness. So I think what we want to do is probably scale this by some value. And then, well, okay. Hey, Lo-Fi, thank you for the follow. Hey, was that Twitch or YouTube? I think it was Twitch, yeah. I can't get the events to work on YouTube. It's kind of annoying. Alright, so I've got this brightness, which is not exactly brightness. And the problem is, it could be... Hang on a second. Dot product of this, maximum 0. Okay, so we can't go below 0. That's cool. But if we multiply this by 0, then of course, that's not a great time. So we probably want to do... something a bit different. Maybe 1 minus brightness. What is that going to give us? It's probably going to give us a very weird result. Actually, that looks pretty okay. All things considered. We don't exactly have a proper color. Yeah, so the thing is, this normal, we probably shouldn't have this in there. But it might work now that we don't have, now that we have the brightness, we might get something. Yeah, there we go. Okay, interesting. Whoa. I definitely don't want this, but it's interesting. Okay. think this has got to be different. This has got to be different. This has got to be like an add. No, not an add. I'm gonna have to work it out in a second properly. Okay. This is very interesting. So we've kind of got this reflected thing working, reflected direction. I think it's got to be negative look direction. What if I reverse this now? Okay. As I look towards 0, it's seeming a bit brighter, I think. It's quite dark over there, quite bright over there. But yeah, I mean the the actual scale is just way too much. So if I think about this, this is going to be a value between 0 and 1. We're multiplying it by 0.2, which means it's going to be a value between 0 and 0.2. But we actually want a value between, yeah, we do want 1 minus brightness. I'm pretty sure we do. You know, or I could just do like plus 0.8, which is kind of a weird thing to do, but this is very smoky. It looks kind of smoky. Okay. All right, I'm going to have a little peek at the out color of the previous shader that we wrote. So we had ambient lighting, diffuse lighting, and specular lighting multiplied by the fragment color. Yeah. Okay. So right now we've just got, this is just diffuse. No, it's not diffuse. Is it? Yeah, this is just diffuse. Ambient times sunlight color. Wait, what the hell? Did I? No, the dot product shouldn't. If you have the terms in a different direction for a dot product, is that? Oh, actually, I totally got it wrong. So the diffuse here is a dot product of the normal and the light direction. Yeah, that's what this is. Except not of the normal. Oh, interesting. I totally messed it up. I thought we were finding the difference between the direction you're looking at something and the direction of the sun, but actually that doesn't make sense, because you could be looking at something from behind and then doing a dot product with the sun, but you'd actually want to do a dot product with the normal, which is what's happening here, which makes much more sense. So it's got to be a normal and the sun, but then when does the reflected direction come into it? Or is that just for specular? Alright, that was just for specular. It's not even used in the diffuse lighting. Huh. Well, let's just have a look at what this looks like real quick. No, it's just gray. because I still have this here. Oh, now it's just black. Hang on a second. Right, I've got to multiply it by the color of the light, which I don't even have here. So many issues. I'll just have a white light for now. So this has got to be brightness times sunlight color. And it's still wrong. What? Dot product of the normal and the sunlight direction, yes. Yeah. And then you multiply this, which I've called brightness, which is not quite correct, by the sunlight color, correct. And then multiply it by the fragment color, which is here. Actually, I guess that's not actually the fragment color. The fragment color was... Well, what was it? Oh yeah, it's just a color that I set the same as here. So I guess I need ambient lighting. Or maybe I messed up something else. So I'll just remove that because it's confusing. We don't need the look direction because we're not doing specular. The sunlight direction is backwards. Right, I remember them saying that actually. Okay, that was a big problem. Okay. Well, I failed at reproducing it without looking at the previous version. That's okay. It happens. There's no point being stuck for a million years. I think 10 minutes was long enough. Or however long that was. So we've got sort of lighting. But not great. So it's definitely working though. You can see on the bottom here it's looking darker. On the top it looks brighter. That's good. Alright. So I'm going to write a function here called I'm not sure. Produce sunlight. Calculate sunlight, maybe? Or actually, I'll just call it calculate. Yeah, you know what? Sunlight is fine. I'm just thinking in the future I want to have moons and stuff that also reflect light, but let's think about that much later. So calculate sunlight, and it's going to return a vec3, and it doesn't take any parameters because it doesn't need to, I guess. So we're going to say diffuse equals, actually, why don't I just call it calculate diffuse? No, that doesn't make sense because there might be other lights, right? Yeah, so it's not actually diffuse, it's just sunlight. Okay. Out color, let's say sunlight plus point light. Actually, I'm going to have to iterate, so we'll just do sunlight for now. take this here. So the sunlight has no specularity at the moment, and it has no... What's the other one? Ambient. Which is a little bit weird, I guess. Maybe we should make some ambient. Ambient equals 0.1, and then we'll just return diffuse plus ambient. Maybe we'll put a little to do here. Make better. Okay. All right, now we've got to make a function that can calculate a point light. Calculate point light, and it's going to take in a point light, I guess. That's the wrong language. Struct point light is going to have a position. It's going to have a color. It's going to have a diffuse and ambient. You know, I just realized I don't think we actually did attenuation. We're looking at it, but I don't think we did it, did we? Did I do this? I don't think I did. Oh, maybe I hard-coded it? No, I didn't. Okay, well, I'll have to do this as well. So we've got a point light. For now, I'm just going to put diffuse and ambient in here. And what else do we need? Just position color. Well, maybe some kind of brightness value. Although I guess that could be handled by color. I'm not sure, because usually point lights are over an area, right? So, you know, if you're really far away, or if an object is really far away, like let's say there's a point light here. And then it's got a radius that might be something like, you know, this. And so this represents the hard fall off of the light. So after this, you know, the length of this, you can't really see it on the objects anymore, I guess. I guess light doesn't really work like that, but it would definitely be really bright near this part. That's what attenuation is for, right? Okay, so I guess we have to put attenuation in here. So that's fine. So we're gonna put in. Hey Emilio, how you doing? We're gonna put in the attenuation floats, constant, linear, and quadratic, I suppose. And then to calculate a point light, we need some of the stuff that I had in there previously. So we've got light direction is going to be the position of the light minus the player's position. Or is it the player's position minus the... Yeah, player position minus light position. I might have got that backwards. Player position here, light position here, player position minus light position is going to move this over here, and then we operate as if we're at the origin. Yeah, I think that's right. Actually, we can do this. So it's normalizing a vector, right? So we just grab this vector like this, and we can kind of eyeball. If we move this light, you got biscuits today? Nice. I'm jealous. I had to give up biscuits because I put on like 4 kilos. I think I was eating too many biscuits. I was eating one of those big family packs every day, pretty much. I don't know if you guys have them. I don't actually know where you are, but it's like 500 grams of biscuits, which is just crazy. What kind of biscuits did you get? And so we want to actually just put this here, and then the new position for the eye is here, right? And I can't remember what I was doing. Got distracted by biscuits. Oh yeah, we've got a normalized direction. Yeah, right. So the normalized direction from here to here. Yeah. So it's player minus light position. Now you know where the limit is? Yeah. Definitely don't eat that much. Unless your metabolism is really good. My metabolism used to be really good. But I also used to smoke a lot. And I was younger, so maybe a combination of those two. Oh, you got a Hershey's filled biscuits. Sounds good. All right. So we got the light direction, and then we need to calculate what? Reflected. Actually, that's just for the specular, right? For the diffuse, we just need something like this. Look at the light direction, the normal. Yeah. I'm going to call it brightness again. I'm sure people get annoyed about that. Okay, and then this is basically exactly the same. Times the light color. And I'll also use a simple ambient of 0.1, I guess. Okay, so we've got a point light now, allegedly. Let's make one real quick. So we'll just make a point light here. I just don't know the construction for structs in GLSL. Can I do like dot field syntax, or is there no dot? Or do I just have to do it in order? So I'd rather just do this right now because I don't know. So the position can be 0, 1, 0. Color can be, let's do a different color this time. Last time was green and it was looking a bit sickly. Let's try blue. We haven't done much of blue, but we'll do a different blue. We'll do sort of a teal color. And diffuse is going to be, oh, I should have actually, I don't know, I don't need to. So we haven't done attenuation yet, which we'll need to do shortly. But let's see what we got if we do Vec3 light color is calculate point light, pass in our light. Now we do model color times sunlight plus point light. Is it going to compile? No. You always did them in order? Oh, right, I see what you mean. Yeah, the structs. Undeclared identifier point light. Oh yeah, it's not called point light, it's just called light. Okay, still an error. Plus wrong operand, no operand, blah blah blah. Left hand side is a vector and a float. What are you talking about? Where did I add a vector and a float? It said the line number, but I just didn't read it. Where is it? 55. Okay, it's here. Oh, yeah, I'm trying to add a struct. Okay, what about that? Success, very good. Okay. Oh, what did I mess up? Whoa. Oh yeah, I got that error again because... what did I do wrong? You can't see the light until you're inside the light's bounds, which is not what we want. It doesn't make sense. But there are no bounds. Alright, what have we got here? Point light... Specular strength. No. This one. Normal point light direction. Light position minus frag position. Oh yeah, I did that thing again. Yeah, this is wrong. Calculate the point light is totally wrong. So we don't want to subtract this. We want to subtract... If we're looking at, let's say, this pixel here on the ground, we want to subtract, what was it? I just looked at it. I wrote this code earlier, but I was following a guide and I'm just trying to reproduce it without looking, but I'm failing. This light position minus frag position. So this position minus this position, which means this position minus this position. That means we're going to go all the way over here into the negative. In this case, or I guess in, not in all cases, but in this case, yes. And then the OpenGL, learn OpenGL, it's so good. Yeah, it's really nice. It's got so much stuff in there. What am I doing? Running the program. Okay. Great. That works. I'd like to know why it works a little bit more. Right? Like what? This light seems to have a direction. Do you see that? Sort of that way. And then this way, it's just like, nah, I'm good. Which means I probably messed it up. What time is it? It's 4:45. All right. I've got another, say, 4 hours in me. I reckon I can program for another 4 hours. I want to figure out what the weird thing with the, looks like a cone. That's a bit odd to me. Did that happen last time? I don't think it did, but maybe. Well, to be fair, I didn't use the reflect, which was supposed to do... Wait, why do we do that? Reflect direction. Just for the specular lighting. Okay, we don't need that. So... point light diffuse times light color, yeah. Pretty much the same. You remember having trouble figuring out how to use the correct libraries on the linker field when switching to Linux. Yeah. That stuff is really annoying. I mean, linking, and especially things like on Windows, if you look at the compiler flags, there's like /mtd and /mt something, and it's like one is a multi-threaded dynamic library and the other one isn't, or something like that. And you got to make sure that all your libraries are using the same type. Yeah, there's a lot of really confusing stuff. That was close. I almost spilled coffee out the left side of my mouth. All right. Why do we have a problem here? Ambient strength times light color, and then we just add the ambient. Point light ambient, yeah. I've just added a white, so I guess we should times it by the light color. Same with this for the sunlight color. Okay, I know there's no fall off or attenuation yet, but see, that definitely looks like the light's at the center, right? I'm not crazy. That's 0, 0. We spawn at 0, 0. The light looks like it's there at its brightest point. Even if I go over here, it looks brighter over there. But why is it like covering this side? I don't get it. I'm gonna do something in main. I'm gonna say when I press a button, maybe E. You think there should be a guide that needs to get popular for navigating linker flags in library versions? It can actually save years, or save early devs giving up. I agree. No, that's not a format print. I'll just print the position like this. Alright, so when I press E, it's going to print the position. And let's look at what is my position. Is it 0? Yeah, I thought so. This is 0, 0, 0. The light is about here. Well, actually, it's much lower. This is about where the light is, I guess. Is the point light too close to the scene? Yeah, maybe it is. Maybe I'll raise it up a bit. We'll have a look. So it's at 0, 1, 0. I was just at 0, 5-ish, so I'll put it up there. That's weird, right? No, it's definitely weird. It's definitely off center. Something is wrong in my math. It's gotta be. So let's have a look at the old code again. Actually, I don't even know if the old code was correct. So let's look at the code in here. Point lights, And okay, I'm just going to look at the result. The shader is somewhere here. Light casters, yeah. All right, let's have a look. So we're basically just doing diffuse and ambient right now. So we got diffuse here. Light position minus frag position. Yeah, that's correct. Using a dot product of the normal and the light direction. That's right. The diffuse is brightness times, we don't have textures right now, so yeah, basically this, light color times brightness, that's what we're doing. Okay, if that's the case, then maybe my normal is not normal. No, that didn't do anything apparently. What if I just... This shouldn't make a difference. It would be exactly the same, but I'll do it anyway. The light direction is normalized. The position, I don't get it. The light position. Yeah, 0, 5, 0. But it's like, yeah, just appearing to light this area more. Like, okay, what's my position here? Yeah, negative 2.6, negative 2.5, negative 1.9. Would it matter that the color is not normalized? No, the color has to add up to... Actually, I believe the colors can go above 1. I don't think so, because if the color is normalized, it'll make it all muted. So if we look at this, because now each component can't go above 0.33, right? Basically. Wait, did I just normalize? Oh yeah, no, I did normalize that. Hang on a second. Maybe you're onto something here. But now it doesn't look like a point line, it's just lighting the whole scene. But maybe that's where attenuation comes in. Well, let's see, result, no. I'm pretty sure. Okay, maybe we'll just leave it. I'll implement the attenuation as is discussed. And then we'll see. Because we have got no fall off for the light right now. So I'm just going to say, I'll use the values here. Constant equals 1. Light dot linear equals 0.09. No, you're not leading me in the wrong direction. It's all experimentation. I appreciate the input. I don't know what I'm doing. Well, I mean, I have a vague idea. But I just want to get way, way, way better at graphics programming. So that's why I'm kind of starting from the simple lighting that we're doing now. And trying to sort of work stuff out again to make sure I really understand it instead of just copying the code. So if we calculate the light color, we're going to do that in here. So we're going to have a distance is the length of the light position minus the frag position. Okay, that makes sense. So that's going to give us if we're drawing this, it's going to give us basically the length of this vector. It was weird that some vector wanted to point in the direction player pos was at that one time. I don't quite follow that one. Sorry. One divided by light constant plus light linear times distance plus, yeah, this makes sense, light quadratic times distance times distance, yeah. Okay, that matches the formula, that makes sense. And then okay, that's all good. That looks almost better, but as you can see, it's still kind of off center. Unless when I pause the game to see the what position my camera was at, the vector of the spotlight looked like it was pointing there. Yeah, it did look like it was pointing in that direction. Now it looks like it's working. So we needed attenuation. Maybe there's something in the math that I don't understand that makes it so you get that kind of result. Which is a bit strange, but this still looks off center, but maybe not. Let me see. How could I kind of want to see where the lights are with a mesh or something. And also I want to turn on some kind of console, maybe some debug text. I don't have text rendering yet though. Whoops. Alright, so what was I gonna do? I can't remember. Very good. I love not being able to remember, but if I go straight up, what the, why is it over there? So weird. If I press E, I'm at position 0, right? Yeah, position 0. So the light's just over here for some reason. I don't know why. I mean, obviously, it can't stay like this. You can't just have lights that move by -1 in your engine and you don't know why that happens. Yeah, interesting. Okay. I'll put it at 0, 0, 0 again. I know it's going to be still off center. Well, wait, it's not. Oh, okay. Interesting. I think it's maybe not off center. It was just high up enough that the directionality made the light reflect over here, so it looked like it was a sphere floating up here, but actually it's not. Really interesting. If you want to survive in the games industry, you can't have your spotlights moving in the negative direction. Yeah, that's right. Toxic positivity only, please. Wow. Okay, so it's doing this thing again. Bro. That's really strange. What if I turn off the sunlight? I don't think that's going to have any effect on it, right? No. But we can clearly see this is not correct for a point light. Something is incorrect here in the math. I'm going to look at this again. All right, let's go over this one more time. Diffuse. Normalize the normal. Normalize the normal here, that's fine. The light direction is the normalized vector, which is light position minus frag position. Wait, actually, let's look at frag position, because this might be wrong somehow. I don't think model times, well, this is just an identity matrix, so this actually doesn't do anything, right? I think. So if I just set this to vec4, I don't know, is it a vec4 out? No, it's a vec3, which this already is. What happens? Same thing. Okay, I just wanted to remove transformations that didn't do anything, but I guess since it didn't do anything, I can add it back, because otherwise I'll forget about it. And later I'll move things around and wonder why it's not working. Okay, so I've got a max between the dot product of the normal and the light direction, and 0. That's going to be our brightness factor. Down diffuse is going to be the light diffuse, which we've got as, actually we don't have a color rotation. Oh yeah, right. Yeah. Doesn't look like anything is going to be rotating this. I don't understand how this is happening. I mean, obviously I don't, but it's just really weird. So we've got light diffuse. What is that? I think that's the color. So I've got color for some reason instead of diffuse. I should probably just have, that's what diffuse is, right? Okay. Now the ambient is just going to be the light ambient. What does ambient do in this one? Light ambient times texture. Yeah, so we just return light ambient here. And we set that to, let's say vec3 0.1, 0.1, 0.1. Okay, so diffuse, light diffuse multiplied by brightness. We don't have a texture, so don't worry about that. Okay, now we've got attenuation. So we don't have specular right now, which I think is fine. Distance is length, light position minus frag position, yes. Attenuation is 1 divided by light constant plus light linear times light distance plus light quadratic times distance squared. That's correct. Multiply these values by attenuation. Add them together. And that gives us this. I don't get it. I don't get it. We're not even using sunlight right now. The code looks almost the same. I don't think we're doing anything different, except we don't have materials, but that doesn't matter. That's so bizarre. View position, that's only used for specular lighting. Maybe I'll try adding the specular lighting. What if I use the model matrix to move the point light up and see what effects are at a higher point? Yeah, I think I could do that. Where is it? The model is coming from MVP. Actually, it's going to move everything up. So this model is actually not referring to the light. It's referring to the model, which is the Sporza thing, the actual building. But I do have this uniform here, light position, which we are not currently using. So we've got player position and light position. If I set the light position to this value, I think it's going to start rotating around. Yeah. Oh, hang on. I removed something from here, didn't I? Diffuse. No? I guess I just... Maybe that's set to 0 right now. Oh no. It should be. It's really far away, right? So we'll just do like a 10. It's rotating kind of like a sun, except going under the ground and coming back up. It seems kind of okay. And this... Alright, I'm gonna have to figure out how to draw other things so I can track positions of things better, like debug shapes and things like that. I mean, I know how to draw other things, I just need to add them to the vertex buffer, but probably use a different vertex buffer and a different shader to draw them, which is a bit of work, but not too much. Yeah, I reckon we could do something. So we got a graphics pipeline here, which just has a default vertex shader and fragment shader. Well, not default, but the ones that we were just working on. I could make another one for debug stuff. You can make a single debug square and do the fragment shader. You mean I could draw in the fragment shader? Is that what you mean? Sorry, I'll be right back. I'm busting to go to the toilet. Alright, got some water and a baguette. I'm ready. Debug the fragment shader by drawing on a new square. We can control all the matrix/position of the square so we would know for sure. Oh, I see. So instead of drawing this huge model, yeah. Gotcha. Let's do that. I agree. That's a good idea. Remove potential complications, because I don't know, could be some weird things happening with the surfaces of this model or something. Just got to get the baguette seated on my lap. There we go. All right, good idea. So, what are we doing now? We're creating a vertex buffer. In main, it's got a bunch of vertices, a bunch of indices. So I'm just going to do this. Append vertices buffer. Let's see. We'll make it position is going to be, let's do 10 by 0 by 10. Actually, we'll do -10 by 0 by -10. And then normal will be 0, -1, 0, I believe. Okay. So that's 1, and then we're just going to do 2 vertices, and we'll use the index buffer since we've already got it set up. Did I say 2 vertices? I meant 4 vertices. So 10, 0, -10, and -10, 0, 10, and 10, 0, 10. So it's going to give us a square, right? I think the normal's always up, I guess. And then I'm going to append to the indices buffer. What are we going to append here? Let's think about it. So I think it's 0, 1, 2. I'll just draw it real quick. I can't remember which side we're doing culling. Clockwise. Front face is counterclockwise. Okay. So that means we're going to do counterclockwise this way. So we're going to do, I can't even remember. -10, -10. So that's, and then we went across, and then we went up here. Maybe we should change this to here. So it's like that. And now we do 0, 1, 2, 0, 2, 3. Yeah. That should give us the correct order. And then we just say if false. And that's never going to run. I don't know why I did this. I think the normals are going from -1 to 1, which I think that makes sense actually. I'm just going to get rid of that. Okay, and what do we got now? If I compile this, is it going to run? Apparently it successfully compiled. But we have nothing in the scene. If I go to render doc. Do we have any values in here? We're drawing 6 vertices. We've got a mesh. I might have done the winding order the wrong way. Okay, so in that case we need to flip it, I guess. Wait, actually we spawn in the ground. So let's just say camera.position .y equals 5, -5. No, 5. Yeah. Okay. I don't see this thing. I'm gonna go down. I think I'm going down, right? Down. Oh, what is that? Oh, there it is. Okay, so yeah, wrong order. Whoopsie daisy. Needs to be the other way, I guess. So 201. 201 and 20. No, that's the same order. I need to go 210 320. Is that a part of Odin? You mean this? This program is called render doc. It's really useful. So if you can't get something rendering on your screen and you think everything is working, you have no idea why, you can come in here, you can press Control N and it'll bring you to this part where you can put in your binary and your working directory, and you just press launch. It'll launch, and then you press F12 to save a frame, and then you quit. It'll save your frame here, and you can see on the left it's got the whole submission process. So we began a render pass, we drew indexed vertices, we ended our render pass here, we submitted our command buffer, and then you can even look at the different stages of the pipeline. You can look at the buffers, you can look at what data is in them. For example, I don't know what this is actually, what did I look at? It's really, really useful, yeah, definitely. So, like for example, when you're doing a compute shader, something with a compute shader, this is really good as well. Yeah, it's just great. So you can look at like this uniform here. I can be like, oh, what's in the uniform? Is it valid? And you can save formats. So you can format your data in different ways. So this is just vector3 after vector3. But I think actually this should be maybe vec4. I'm going to make a new one. Yes, new apply. So vec4. I will wait. Yeah, vec3. Okay, vec4. Yeah, it's really useful. I wish I could zoom in on it though. That's one of the biggest things, because maybe there's a way in here actually. Global font. Yeah, there is. Okay, I can make it a bit bigger for you guys. There we go. Okay, cool. You can't see everything, but it's a little bit easier, I think. Yeah. Anyway, I love this thing. It's the best tool that I learned how to use in the past. I think I learned it like 6 months ago. I heard about it for years, but I just never used it. And I was always, you know, programming OpenGL, and you just get the black screen and you're just like, what is happening? Pulling out your hair. That's why I have no hair now, because it was just years of doing that with OpenGL. I just pulled out all my hair. It's just gone. It's clear on 1080p. Okay. Cool. So we got our quad. It is black. So maybe you want to give it a bit of a... I mean, I guess that's fine. Yeah, let's actually add the sunlight back, I guess. Oh, whoa, what just happened? Okay, so I got the model color, which is sort of a gray, and we'll add the sunlight back, so we should get at least something. Not really. I mean, I guess it's... I think the normal might be wrong. Is the normal supposed to be 1 or -1 on this one? Ah, yeah, there we go. That looks better. All right. I'm going to make this point light brighter, and I'm going to make it go back and forth on one axis instead of rotating around the Y axis as well. Where is it? Here. So just get rid of that. And we'll set the light position to 5 or something. Go to the fragment shader. Cool. And we'll change the diffuse to a brighter color. Yeah, I think you're right. That looks pretty normal to me. What do you reckon? That looks like a moving point light, not pointing in any weird directions. Interesting. Does that mean there's something wrong with the normals in the model? Maybe because I was normalizing them. Or something. That could have been a problem. Yeah, that's definitely correct now. So that's cool. I'm gonna just do this again with the model. I think that should just load the model, right? Yeah. Hold it at the origin and then increase the Y. Okay, sure, we can do that. I think the problem was the way I was altering the normals, but let's see. There's a lot of commented out code now. So we'll just go up and down on the Y-axis here. Would you look at that? That looks pretty good. Time to eat some baguette. Yeah, I'm just eating plain bread. All right. This is good. So we've got point lights, we've got sunlight. What we don't have is any occlusion culling. So actually it'll be more apparent if I go down here, behind here. You can see the light just goes straight through the wall. It doesn't even care. I kind of want to figure out how that works. Seems like it might be an expensive thing to do. All right. The Feast of a Champion, yeah. Cool. I'm pretty happy with this. Thank you for the suggestion. Couldn't have done it without you. So, what's next? Kind of want to shift gears and do None of these things. Multi-channel sign distance field text. I've done this before, but yeah, I had to use this tool, MSDFgen. It was actually pretty easy. Well, I just copied that shader basically. But the gist of it is it's a way to make text using sign distance fields that look really good. As you can see, this is their version. This is the version that I think Valve made, which was just a single channel sign distance field. And then this is just a scaled up version of that one. So this one has no weird artifacts. Yeah, I kind of want to be able to see stuff on the screen, like position and, well, actually, do I really need that right now? Maybe a better thing to work on is that debug pass. Like a render pass for debug objects. Let's just delete this. And I'll leave this here because it was useful. Okay, let's see. We've got pipeline, graphics pipeline, create. Okay, so we're going to make another pipeline here. So we're going to create a graphics pipeline. Let me grab this. With the vertex shader of debug.vert.spv. Farag. So now that we're creating two pipelines, or we will be shortly, I have to actually modify the pipeline creation to take a few more arguments, I think. So this is complaining because the files don't exist. Yeah, that's fine. We will make them, whoops. So we want to make shaders debug.vert.glsl void main blah frag color equals white or something. That's fine. And then we want a shaders slash debug.frag.glsl. And out color is going to be flag color, and then I'll just do. Why am I typing all this manually? I can just copy it from the other ones. So I need. I guess I do want vertices and colors. So actually, I will just put this in here. And I want to send out. I don't need. Maybe I do need that. No, that's for lighting. I don't think I need that. Just the color. And what else? I think that's all for now for the vertex. Now I'll go open the fragment shader and we'll say we want the normal and the frag position. That's not what I sent. Oh yeah, I named them different things. We just want the frag color. So this is just frag color, and then that's it. But we also need to send out the out color. There we go. Out color is frag color. Okay, that should compile. Let's see. Apparently not. On line 8, because it's a vec3, so this needs to be vec4, frag color 1. And, okay, on, wait, what was that? Line 9, I think, of the vertex. Yeah, this is just vec3 1. Okay, great. Cool. Actually, I'll just change this to the color. Do we need the position? What do we even use the position for? I'm having a brain fart. Oh, we just need a... Yeah, we need this actually. Something like this. And we also need this then. Alright. Don't care about that. Alright, so we've got simple debug shaders. All they do is draw colored vertices. We still got a compile error because we're expecting a semicolon on line 14. Yeah. Okay, cool. So these should exist now, and you can stop complaining, please. Thank you. Good. However, what's the difference between these? Actually, nothing. So I guess so far we don't have to change anything. These are just going to be the same. Although, actually, I don't want to turn on depth testing for the debug renderer, I think. Do I want depth on debug shapes? Probably not, right? I'd probably want them just to appear on top of the screen. Yeah. Well, I'll just leave it for now, and we'll try to draw a sphere. But the only sphere that I have is crazy GLTF sphere, and I don't really want to draw that. I just want like a, maybe an isodecahedron. Is that the right word? Dodecahedron? Which one was I thinking of? No, it was maybe it was dodecahedron. Okay. Alright, let's not get too crazy. Just give me like something like this. What is shapes similar to dodecahedron. Okay, I need to look up the isocahedron. That's what I wanted. Icosahedron. Yeah. Yeah, give me an icosahedron vertices somehow. Yes. I don't want to load a GLTF model just for this. I know it's just a few bytes, a few floating point numbers. It's 12 vertices. MathWords? Is MathWords a website? Or are you just saying that I'm saying MathWords? Build the unit icosahedron. Yeah. Hey, would you look at that? What the hell is this? It's a dictionary of vertices. That's a bit interesting. Just saying they're complicated. Right. Yeah. I'll just get a GLTF of it. There's probably one, right? Actually, I may as well just use the sphere. I've already got the sphere. Alright, I'm going to turn this into a function. I guess I'll put it in the renderer since it's to do with loading. But it's not to do with rendering, so maybe not actually. Client, GLTF, I guess. Actually, maybe it shouldn't go in client. Is the server going to need to load GLTF models? Probably. Okay, GLTF load vertices. I'll just make it really simple. And it's going to take a GLTF path and a bin path, which is going to be C strings. Yeah, I'm working on this engine is going to be multiplayer, so I actually already had a multiplayer test working before, but now I'm just working on rendering stuff, so it's not in there right now. This is going to return something. Okay, I'm probably gonna have to change this soon, but not soon. I'm definitely gonna have to change this later. So we need to pass in an allocator, but we'll just say context.allocator by default because it's gonna allocate some memory, right? Yeah, so it's gonna make these buffers, which I don't have. So the way I've got it split up right now is I've got basically client, core, renderer, and server. And anything that's shared between the client and the server goes in core. Renderer is sort of its own just black box thing because even though only the client needs it, I just felt like making it into its own package. I guess it could live in the client, so it would be client renderer. Yeah. Have I released games? I have released one game, but it got removed from the Google Play Store because Google wanted me to sign some new agreement, and I had like 3 months to do it, and I didn't do it, and then they just removed it, so yeah, but it didn't get many players anyway, so it's alright. It wasn't a big game. Vertices buffer. I guess we don't have a common vertex type right now. I just kind of hard-coded it in the main file here. This could be an issue. But it's alright. I'll have to sort that out later. Indices buffer is going to be 32. Actually, we're going to make these. Okay, and what's next? GLSL. Did I use an engine for that game? If not, what was the release process like? I actually did. I used Unity. This was quite a few years ago. So it was pretty easy. I just built for Android, and then there's a bunch of stuff that you have to do on Google Play. I can't remember. It's been ages. But I remember Google Play is pretty annoying. You gotta wait for it to get approved and stuff. Although there was nothing, like it was like a geometry kind of game where you're like a flying, spinning circle and there's rectangles trying to hit you and stuff. So not really anything to be moderated there. Okay, why does that keep happening? That's really annoying me, actually. This gap keeps getting closed for some reason. Oh, because this doesn't have enough braces, or it has too many braces? No. I don't have the right amount of braces already. What is going on here? Something is broken. Apparently not. Apparently that's fine. It just really doesn't want me to have a space here. I think I probably need to quit. Oh, yeah, this is going to be broken now. So it's more than you've done and probably more than you will do for 2 more years. Well, yeah, I'm kind of on the fence about this particular issue because, you know, every now and then I think, man, maybe I'm making stuff the wrong way and I should just make a game in 3 months and release it so that I have proof or something, or like so that I can prove to myself that I can do it or whatever. And then I watch or listen to like a podcast with someone like Billy Basso, who made Animal Well, and he's like, yeah, I worked on my game for 7 years. Although mind you, he was a game developer in his day job anyway, so he already did release games, I guess, for the companies he worked for. And then I listened to the story of someone like Chris Hunt, who is the creator of Kenshi, the game, and he spent like 9 years on that game, I think, and 6 years was solo, and he was like working part-time as a security guard and just working on the game as much as he could, trying to scrape money together. It's a pretty inspiring story, actually. So yeah, I don't know which way is the right way, or if there is one. I just know that giving up is the worst thing. So if you think that you can't do it for a long time, or if you're sure that if your project took you like 5 years, that you would just give up and you start a big project, then I wouldn't do that, I think. I stopped working on a couple of games already. But it wasn't really because I got burned out. It was because I couldn't find the fun in the games. So like I had this idea, I thought the design was really cool, and I thought it would be interesting, and then made a prototype, which still took a long time because it was pretty complicated. And then like a couple of months at least, 3 months, 4 months. Yeah, and then just played it and was like, not really sure if it's working how I imagined it, and then iteration was really challenging, I guess. Yeah, I've done that a couple of times. I've also restarted projects for no reason for years, and that's a really bad idea. So definitely don't do that if you can help it. Yeah, so I didn't actually set a return type to this. I'm going to return pointer to I'm probably going to change the way this works later. I'm already not liking it, but that's fine. Yeah, let's return pointers to these things. That's not going to work. I need to make these. Yeah, that's fine. So make returns. What is going on with this file? Oh yeah, I was going to quit, wasn't I? There we go, that's better. Sometimes the formatter gets confused. Well, obviously I can't return a pointer here. I've got to... I guess I need to make a new... But you can't make a new dynamic. Oh, you can. Okay. There we go. That's what I wanted. Amazing people, and you're always on the fence of funding and also sort of focus. You have a programming job and the subfield of programming for the job is a completely different subject to learn. Yeah. And the learning curve is pretty difficult. Find yourself having to do research for your job rather than stuff like rendering fonts or mixes or whatever. Yeah, that's a bit tough. I previously worked in web development and I thought, yeah, I'm going to work as a front-end developer or whatever I was. I think I was front-end most of the time. Sometimes I did back-end, that's why I was a bit confused. And then I was like, yeah, and then after work, I'm going to come home and I'm going to make games and it's going to be awesome. And then I would just use all my mental energy figuring out dumb React stuff. And then come home and then just be like, nah, I don't really feel like programming more. Which is kind of a shame. So if I were to go back to work, which hopefully I'd never have to do, as long as my business does well, I should be alright. But if I got to go back to work at some point, then I think what I'm going to do is I'm going to set my routine up so that I have maybe like 3 hours every morning before work where I can be really focused on whatever it is that I want to do, like a game project or whatever. And then I can use the rest of my hours for work. So I get the best 3 hours of the day to work on my thing, and then the rest of the day is going to be working the day job. Because a lot of the time with these day jobs, I mean, sometimes they take a lot of mental energy, but a lot of the time it's just like filing Jira tickets and like talking to people and having meetings and whatever. And like that's draining as well, but you don't need your full cognitive abilities for that stuff. Okay, let's see if this works. We should be able to load vertices from this function now, hopefully. We did not succeed. We failed. Okay. Alright, that's okay. File not found. Well, that's an okay error. Sponza. Did I call it Sporza? Yeah, it's Sponza. Okay. What? Oh. This pipeline is being loaded. Yeah. Okay, cool. Interesting. Maybe you can make it work soon, reschedule your days. Not a bad idea. Yeah. It sounds like a really good idea. I didn't make it up. I heard it on, I think it was a podcast or something. It does sound really good. Luckily, right now, my daughter just started daycare, so I actually get to work again. Whereas for the last 2 years, I've been basically only able to work like 2 days a week, which has been pretty tough. And I'm in work like on my business, and I have paying customers that I need to deliver for. So it's really important that I do that. Today is special. I wouldn't stream this long next week. I'm not gonna have the time. But this is like the last day that I have where I don't have my daughter and I don't have other obligations right now. So I thought I'd celebrate by streaming for a long time. Cool. So the way these pipelines work, if you notice why it just went all, it just got colored with the normals, is because I automatically set the graphics pipeline when you make one, just because remind to drink coffee and or tea. Yeah, thank you. Just because I thought it'd be easier to have sort of like a semi-state machine sort of thing, where you make a pipeline, you probably want to use that, right? So I just set it up to automatically get bound, essentially. But what I'm going to do now is I'm actually going to I quick create them in the opposite order, which I'll probably just do that. So I'll make them in this order. So I'll make the debug one first, then I'll make this one second. I'll just put this in here. There's no need to have a separate variable for it, I guess. And so now the stuff that we're rendering is going to be rendered with the second pipeline, which is what we want. And now if I want to render debug stuff, I can do render state dot graphics pipeline equals debug graphics pipeline, which I haven't made yet. So I'm going to actually save the pipelines as variables up here. Where are they? Up here. Okay, so this is the debug one. I'll just call this default graphics pipeline. Okay, so we'll do that. Actually, I think we can... Is it a variable in somewhere? No? Drawing begin? I thought it'd be in drawing begin, but I guess not. This is not the way you're supposed to do it. You're supposed to do it with... render pass begin. But I also need a swap chain texture and a command buffer. So I think what I'm gonna do is I'm actually gonna add more optional parameters to the drawing begin function. Like, for example, which render pass we're referring to, and then I'll leave everything else the same for now. So render pass is going to be, no, not render pass. I want graphics pipeline, not render pass. So maybe graphics pipeline equals nil. Okay, now if we do here, renderer dot drawing begin graphics pipeline equals, wait, this is going to be a problem. I just realized. We're going to be drawing on the same target and we're going to be clearing the screen each time. So we need to do, god damn it. Need more options for the graphics pipeline basically. So okay, the quick and dirty way is I can add an option to the graphics pipeline options here that says something about clearing the screen. So let's see. Where is clear? Clear. Color target. Wait a second. No, it's on the render pass. Is it on the render pass? Yeah. Okay, so we've got to make another render pass. Not another. Okay. Okay, here it is. I was just looking at this. Okay, let's see. I'll see if I can do it manually. So renderer dot, what do we need first? Command buffer, I think. Command buffer acquire. I'll just make a new scope here. And then we need render. We need a render target, but that's going to be the same render target we just rendered to. Yeah, this is a problem. Okay, so basically this function, render pass begin, does not allow us to determine, does not allow us to specify whether we're going to clear the color target or not. So if we look at this, we could do, I don't know what load does actually. So what does it do at the beginning of the render pass? In our case, previous contents of the texture will be preserved. Yeah, so we want load, right? So I'm trying to think of the best way to do this. Not best, but just a way that's not gross. So let's see if we got, if I actually just put it in color target clear op, or maybe color target clear as a boolean. Equals true by default. And then here we can put color target clear else load. That might work. Let's see what happens. We'll give it a go. Render pass begin. We need to pass in, we don't need the clear color really, so we need, but I'll pass one, no clear color. We need the command buffer, which is going to be command buffer Very good. The render target, we don't need to set that because it's already set. Depth texture, we're going to leave it the same. Graphics pipeline. Yeah, graphics pipeline is debug graphics pipeline. And the color target clear is going to be false. All right. We should be okay to do that. So we didn't acquire the swap chain texture, so we need to do that actually. I think. Actually, let me think about this. I think maybe this is not correct. Maybe what we want to do is... no, I think this is fine. All right. But this is going to get a new swap chain texture, which is not the same one that we just rendered to. So maybe we leave it. I'll see what happens if we don't do it. See if it breaks. Okay, so render pass begin, and then we do all this stuff. Okay, and then we got to draw something, right? So we can say we're going to bind debug vertex buffer, which we'll have to make in a second. And draw index debug index buffer. No, debug indices. I don't like this naming convention. It's alright. 1 0 0 0. That's fine. So we're only drawing one something. Okay, what does this do again? Drawing end. Render pass end. Command buffer submit. Yeah, so the thing is, if we pass this command buffer into render pass begin, we need to set the command buffer as well. So basically we're going to say state command buffer is resolved. No, resolved command buffer, please. This isn't the only place that I need to do this, I think. I need to do it everywhere that we bind, right? So we say, like, if the vertex buffer is bound, then we got to set state dot render pass equals to resolved render pass, because maybe we passed in a new render pass. No. Actually, this doesn't make sense. Shit. I think my API is bad. God damn it. Okay, I'll just do this for now, and we'll see what happens. Oh yeah, this has got some bugs, and also we didn't make these vertex buffer things. My aircon turned off again, man. This building. Yeah. Okay. So we're gonna make some vertex buffers and etc. So I'm gonna say, I'm just gonna copy this. Okay, this is gonna be debug, and we're gonna load the sphere. Why not? Now we're gonna make debug versions of these. And this is going to be Yeah, actually, I'll just do this. Debug. And over there as well. And over there. I think that's all good. What do we got? We got an error. Okay, that's not really surprising. And the error is something about beginning a compute pass. Render pass is null because why? Because the color target info doesn't exist apparently. What? That doesn't make sense. It's right there. Is this like invalid somehow? I don't think so. Oh no, that's fine. This is just because we have no texture. So we're gonna load, store. Yeah, that's fine. Is it because the depth stencil is clearing? Maybe. I don't know. Nope. Shit. So which one is it? Okay, it's the second pass. Okay, that's fine. Alright, so the second pass doesn't work, which is not really unexpected. So, drawing begin is acquiring a command buffer, acquiring a swap chain texture. So we didn't actually do this. Maybe that's a problem. Okay, yeah, that was definitely a problem. However, this is incorrect. Because this buffer is not the one we want. The debug graphics pipeline is not being used, I think. Actually, maybe RenderDoc can tell us. I should have waited longer to build my abstractions, I think. Wow, that's weird. That's not what it should look like. Very strange. Okay, I'm gonna recapture that. That was weird. Didn't look like that, right? No, it looked... I mean, not normal. It looks very weird. Maybe you can't see on the stream, but there's sort of a jittering effect. Okay, yeah, there we go. I think maybe I pressed close too quickly after I pressed capture, and it messed up the data. So anyway, we've got color pass 1. No color pass 2. Yeah, that's a problem, right? Oh, you could see it? Yeah. It's not looking great. I gotta stop eating just bread. But the only other thing I have is beef, and I don't want to cook right now. The easiest way to fix a bug is to make it not run. True. Okay. This is sort of working, but not exactly working. Probably because I didn't pass in the command buffer to here. Do I need to pass in anything else to this thing? Just the render pass? I didn't pass that in. Yeah, slot 0, render pass. I'll just do that here. What does this need? Draw index also needs the render pass. Drawing end, I'm going to replace with this. And command buffer submit, command buffer. Okay, I think we're good. Maybe. No, definitely not good. That's the wrong model. Frick. Oh. I didn't actually write the vertices to these. So nothing's being drawn, but something weird is happening. Okay, that's weird. So I actually need to upload the vertices. I can't just not do that, eh? Size of 0 times length. I still hate this naming convention very much. Also, I'm just going to copy this and then add debug in front of these. Okay, now we should have updated buffers, and it's still really weird. Let me think. The shaders not being loaded, which, let's see. So when we create the pipeline, we're using the debug one. Yeah, debug graphics pipeline. I guess I should look at these, hey. Oh, I can't look at the pipelines. I could step into them and see them when they're being created. That might help. Two paths. Kind of. We got just two rendering. Two passes. Yeah, we got two passes. So we got a rendering pass here, but it's rendering the wrong thing, which is weird. I think it is. I'll try. Maybe RenderDoc will pick it up now that I fixed all that stuff. Let's see. We've got color pass 1, and that's it. Apparently, you can't do 2 color passes. I don't know. Like, that seems a bit wrong to me. Let me have a look at this. Vertex buffer bind. Whoops. So when we bind a vertex buffer, we need the render pass. Okay. When we begin a render pass, we do set the current render pass to the one that we just began. That sounds fine. But the graphics pipeline, yeah, it's passed in. Debug graphics pipeline, yeah, okay. So that's a bit confusing. What happens if I just turn off this pass? I didn't try that yet. So we've created both passes, but we don't run the, oh geez, okay. Nothing. Can't see anything. I guess that makes sense. Let me think about that. Oh, we're getting this again. Ah. It says undefined image. I thought it was just noise. Huh. Interesting. It's kind of cool. Well, we shouldn't need to call drawing begin because we're calling the things here. So command buffer acquire, swap chain texture acquire, render pass begin. And then drawing end is render pass end, command buffer submit. So I kind of assumed this would work, but I must have messed something up. Yeah, it's pretty cool. I think I am actually going to have a break and cook some dinner. And then I'll come back and stream some more. Alright. I want to get this debug stuff working today. That would be great. We got some simple lighting going, which is really nice. And then remade it. Mostly understanding it. Probably going to need to do that process again. Maybe off stream. Yeah. There's just something wrong with this state machine approach, I believe. I believe that's the problem. So, like, if I just don't make the other... actually, what happens when I do buffer create? Right, so we don't... No, we don't change any state. Ah, it's close to 2 AM. Pretty late, huh? Yeah, thanks for tuning in. I'm gonna head off, but hope to see you soon. Yeah, alright, I'll head off. Peace.